Good morning. Good morning, everybody. Thank you for coming to this new session of works. And let's start with the second keynote speaker, Professor Alberto De Capua from Università Mediterranea di Reggio Calabria. The title of his speech is Designing After COVID-19, Strategies for the Evaluation, Monitoring and Control of Indoor Air Quality. Alberto, the floor is yours.
I can stay in time because in this way I hope to be more understandable to you. I admit I have constructed a very complicated lineup because of the variety of topics that may appear unconnected. But I promise you that there is a common line. The speech present urban and domestic living and how these have been modified by the new needs, concern and fears connected to the most recent global. The contribution highlights how these dimension K elements of our existence and the resistance with the aim to explore the assessment of indoor environmental quality in the living space. I will start with the evolution of the concept of quality and our continuous attempt to ensure its control. A problem that is very much felt due to numerous factors, such as the increase in the complexity, especially technological complexity of the building product. The introduction into the building market of materials, components, and technologies that are substitute for the traditional ones, the lack of knowledge about behavior of building materials with respect to all external actions, and in particular with respect to behavior over time. The most recent warning from international organization about energy conservation, increasing environmental decay. In response to these needs, the traditional concept of quality relating to the aesthetic, technical, and functional characteristic of a construction has been enriched in recent years with quality measured on the basis of complaints with environmental parameters relating both the indoor and outdoor environmental and considering the physical, material, and energy interrelationship between construction and its surrounding. The control of environmental quality of a project represents one of the most recent and essential requirements of design activity, with the main purpose of controlling all those physical parameters related to the conception of the microclimate and confined space environmental comfort, assumed as indispensable and priority the need to achieve safe and healthy environments. Here, the objective is to promote the design and the use of organic regulatory tools capable of promoting conditions of well-being in relation to the place in which the building organism is located, to the activities in the internal environmental of it are exercised, and to the construction methods. In practice, it's matter to define the parameters that relate to the condition and the state of the environmental according to needs resulting from living condition and activity of users with reference to the phenomenon of heat, cold, noise, light, air purity. Things began to get more complicated to the late of 1918, when quality was joined by a new term, sustainability, which entered powerfully into any debate concerning the development models toward which our society should tend. A debate that divides the good from the bad. In recent years, everything that has to do with the architectural design, from material choice to the technology used, has had to deal with this term, the meaning of which, despite trying to place in an unequivocal defining apparatus, always take on a different nuance and meanings. In spite of this, it was nonetheless universally generated. And in the society of recent decade, an awareness that lifestyle assumed will have a dramatic fallout on generations to come. Why them have continued the warning not produced the breakthrough? The studies, conference, and debate are served to understand the emergence to such an extent that an exact diagnosis has been established. We know perfectly well the damage produced by our society, now so truly evident, but we cannot yet glimpse the therapy, or rather, the real will to cure is not perceived. Contemporary culture increasingly conditioned by greater technical and economic availability and greater independence from the natural resource has carried out and carries out environmental destructive transformative action without succeeding meeting the needs of urban quality and well-being for the inhabitants. The consequences of transformation have not produced, except in isolated cases, new ways of being, new prospects for development and new fields of activity on which to apply creativity and social enterprise. In the last half century, humanity has been faced with the possibility of self-destruction and the unprecedented condition of being aware of it. The magic formula of sustainable development, the Brundtland report, in whose idea is encapsulated the realization that it's better to focus on balance rather than unbridled growth, and the meager results of the continued international conference only confirm how far we are from a change of course. To add further aggravation, one of the latest reports commissioned by the G7 members, A New Climate for Peace, calls for the recognition that climate change will be one of the threats to the stability of states and society in the decades to come, with the belief that environmental catastrophe is inevitable. And no longer remediable, and therefore we must put epochal disaster on the back burner. And in the absence of timely and effective adjustment, the ecological turn toward a new sustainable balance will be imposed by such disaster. Indeed, one cannot be indifferent to what is happening, nor to the fact that such outcomes have been caused by erroneous development patterns undertaken more than half a century ago. Important progress has been made in all priority areas: incentive for energy efficiency in building, measure to green transportation system, improvement in the energy efficiency building, revision of eco-design directive and eco-labels, as well as strides have been made in research and financing. However, negative trends persist in several areas, including the growing demand for natural resources, the huge amount of waste produced by the construction sector, or dependence on foreign countries for its energy needs. Yet, this lag does not seem to worry us. Today, the new needs that contemporary life demands of architecture and cities means that the project must become an interpreter of the place and needs of inhabitants through appropriate technological solution, whether intervention in urban suburbs, smaller towns, in the slate of public housing, or in disused industrial areas. Action is called for the guarantees direct and indirect benefit, interprets the desires of communities involved and respond to new environmental paradigms. The aim is to reflect on the key indicators on which the achievement of sustainable quality may depend, with the more traditional construction process. Investigate the new subject areas, supplement existing ones with new specific requirements, relate to the new indicators to the areas of application and the different level of the project. Show the designer the way to improve the building's environmental efficiency performance and to promote the use not only of clean technology, but also the methodology to manage them clearly. It's necessary to define at the outset what is the complex system of principles that animate sustainable architecture today, whatever those exclusive aimed at greater attention to and protection of the health of users and that of the environment. Is it also concerned with social and economic issues at the time when it is proposed as a cultural, social, ecological, and economic change necessary to protect future generations? We believe that the project too long has forgotten to put humans and their well-being at the center of its interest by shifting its focus to the increasingly intelligent building and construction element. The goal is to have the project contain indicators for the assessment and management of health risks related to indoor air pollution, indicating effective protocol in prevention, control, and correction. These actions are generally evaluated in indoor air quality studies and are the basis for economic and social enhancement of indoor air quality improvement action in building upgrades. In industrialized countries, people spend a large proportion of their time, up to 19%, in confined environments, such as homes, public and private buildings. For some group of people, such as children, the elderly, and the sick, the percentage of time spent indoors is even higher. At the same time, in recent decades, there have been profound change in indoor air quality with a progressive increase in pollutants. The origin of this situation can be traced back to one of the many wars that have always been very close to us, the Kippur War. In 1973, in that case too, as we are also saying today, the crisis between two countries led the consequence on our way of living. Italy, following the crisis of the world energy resource, new technical and design criteria have been imposed for civil building. The need to contain consumption of heating and ventilation has imposed a better insulation of building, with a consequent push to seal the interior. The introduction of new materials more performing from the energy point of view and the improvement of construction systems has meant that we live in highly efficient building. But this had led to replace the natural mode of ventilation with artificial means, often inadequate and malfunctioning. Several years have passed from the 1917 to the present, but it seems we have not managed to solve the problem. In fact, the Istituto Superiore di Sanità report number 11 of 2021 noticed indoor air quality is an integral part of the risk management hierarchy. Improving indoor air quality has always been the real strength to promote and safeguard the health of citizens. This has promoted the scientific community to emphasize the importance of air change in mitigation the risks of microbiological contamination. Until today, there is no universal accepted definition of good air quality. Currently, for civil environmental, the definition of ASHRAE prevails, which consider the indoor air quality acceptable when it does not contain known contaminants in harmful concentration, and for which a substantial majority of exposed people, 18% or more, do not express dissatisfaction. The importance of the USI lies in the fact that currently in the Italian legislation, there is no specific reference to indoor air quality, although several commission and research groups have been working for some time. Among these, the National Study Group on Indoor Pollution, activated by Istituto Superiore di Sanità, in which various components are represented, is very active. And even in some Europe member states, the occurrence of poor indoor air quality condition is not yet fully regulated because there is not enough information for risk assessment. Among the different countries, there are very different risk factors and exposures, depending on the use of different materials and construction techniques, different climate conditions, and different habits. Bearing in mind that in defining the right ventilation flow rate, the problem is the need to maximize comfort and minimize health risks, not forgetting to consider the energy consumption related to ventilation. But this direct link between ventilation, airflow rates, and energy consumption is not easy to solve. It's a matter of reconciling solutions to the problem that are in contrast to each other. To deal with certain pollutants, it is convenient to increase the external airflow rate, while to deal with other pollutants, the solution may be represented by a decrease in the external airflow rate. For some decades now, the problem of air quality into non-industrial confined environment has taken a considerable importance, certainly because of the importance of the technical and design implication, but above all, because of the impact that air quality has on people's health. The scientific community to the occurrence or specific pathology and situation of discomfort in the occupants at homes and offices has reiterated the need to investigate the source and agents responsible, to quantify the impact on health of exposure to particular substances or materials, and of course to indicate possible remedies and appropriate technical solution. Therefore, terms such as building-related illness are specific and can be traced back to a precise etiological agent. And there are almost always microbial agents. Typical example of BRI are Legionnaires' disease, from which people still die today, and sick building syndrome. It has a different characteristic from BRI. The symptoms are not specific, and unlike BRI, regress or disappear as individuals more move away from sick buildings, and are now being treated insistently. For some years now, the most developed country, a new issue of primary concern for public health has been emerging. The air that one breathes inside the non-industrial built place is more polluted than the air outside, and this is particularly serious because the majority of population spend most of their time in such place. The home, after decades of a building police geared towards quantity objective, has now become a dangerous place, exposed to radiation of both natural and artificial origin. The problem, I continue to say, is aggravated by the fact that today we are too distracted by uses of energy efficiency, energy conservation, and energy saving. And such indications are totally at odds with the indoor problem-solving strategy that prefer more ventilated and less sealed environments. The term sick building syndrome began in 1976 when a bacterium leaked through the water into the air conditioning system of on a Stratford hotel in Philadelphia, killed 29 veterans of American Legion in American Legion Convention. It was proposed by the World Health Organization in 1983 to describe the set of discomfort discomforts having a specific symptomatology that lead to a reduction in the comfort and health status of the occupants of a particular building or a part of building, where the occupants complain about the quality of the air and manifest symptoms that they are associated with the reduction in air quality. The concentration of pollutants which are harmful to health and living comfort depend on several factors. The introduction of new products into the building cycle, poor design attention to technical solution, decreased ventilation due to the increased ceiling of building. To pollutants of new type or new identified are added traditional pollutants. The result is that a mixture of all the new contaminants is detected inside building, and that this mixture is diluted less effectively than in the past due the measures to contain energy consumption in building, which has led to an overall decrease in ventilation. Add to this a general worsening of outside air, the lack of attention that planners show toward building hygiene and lifestyle habits to the population that make extensive use of products with high pollutant load. In the environmental where daily living activity take place, there are pollution produced by presence of people, animals, plants, by the activity carried out, by air conditioning system, by building material, finishing products, and furnishing material. From the slide, you can see the type of pollutants, how they differ in type and in origin. The main problem also lies in the fact that a combination of factors contribute to the worsening air quality. A clear idea of how this factor can affect indoor air quality and how they should be controlled can enable the designer to develop an effective design for verifying indoor air quality. To this end, real theoretical models have been developed by several parties that define the problem from several points of view. In almost all the studies taken as a reference, it can be observed that in general the factor to be taken in consideration can be traced to the following classes. Air quality control involves all aspects and phases of design, construction, testing, and management of the building plant system. It's a very complex system, and certain attention must be paid from the conception phase to the implementation and then use by the occupants, building seating, climate, building physics, building technology, ventilation and air quality, thermal, indoor climate. General requirements on indoor climate technology. Instead, the European Community study classify them into 4 main categories: physical, chemical, biological, and psychological. Today, the situation is aggravated by what has happened and is happening because of COVID, or rather in an era of technological optimism in which we are convinced that technology can defeat any problem of mankind. Our vulnerability manifests itself even more in the face of the fear of contagious of a disease. But now, since 2009, all the press, media, and new outlets have been dealing with COVID-19 and on a daily basis, offering us a guideline for prevention and the best behavior to take. The fear of contracting the virus is capable of profoundly affecting to everyday life of individuals, negatively influencing a physical condition characterized by states of anxiety and high stress. These states of affairs beyond any ordinance instinctively led us to take refuge in our safe place, the home. In the face of a mature and advanced debate, in this sense, the current context prompts us to deepen the discussion by entering the domestic space of living, asking a new question: how to improve the habitability condition of families living in flat of few square meters? How can we implement the provision of service for the weaker segments of the population, such as the elderly living alone? What can architecture do? Indoor air pollution is still a much debate and investigate problem, and it's one recently that research activity have produced significant results on concentration of indoor pollutants, identification of pollution source, relative emission rates, and the assessment that such pollution has on the health of inhabitants. Result that allows the outline strategy for protection and control of built space from harmful actions. It's important to emphasize that there are strategy and not only technology, because as much as and perhaps more than techniques, it's important to have an informative program on the problem and regulatory action inside and outside of the building process. The development of an air quality verification project in confined environments requires systematic evolution to be carried out in many directions. It must cover both the identification of the contaminants, whose presence is to be measured, and therefore the choice of the most appropriate equipment for the relevant measurement, and the evaluation of all those factors that influence the occurrence of indoor air quality problem and can change the internal concentration of contaminants. Further evaluation concern the number of points at which measurement will be made in the building under examination, the duration of measurement themselves, and the possibility, the number of buildings to be examined. Indoor air quality verification program are undertaken in the order to be able to identify the relationship that exists between the indoor concentration of contaminants and one or more mass balance factors. Sorry. We can see the two-stage development of preliminary research plan and development of detailed field verification project. In order to face the problem, the global approach is fundamental. A building is a system, and as such should be studied and treated in the totality of its interaction. One should not act on one of its parts without considering the effect on the others, and one should not act on air quality without considering the implication in the management, including energy of the building. It's necessary to verify the problems are not solved because of a pollutant substance search by adopting techniques that may have negative effect on the building element or that in turn contaminate the air. According to the USA agency EPA, there are three basic strategies used to control indoor air quality: source control, ventilation, and air cleaning. I'll be speedy on this slide. Ventilation are a different strategy to solve problems. In the field of verification of indoor air quality, the term measurement is used in a broad sense. Its meaning includes measurement carried out through the use of physical and chemical methods for the purpose of sampling and analyzing the concentration of contaminants, air exchange rates or environmental parameters, but it also refers to the use of questionnaires and similar instruments in order to obtain other useful information related to each other, having the same importance regarding the characteristic of the building. Conduct an investigation on existing building is therefore a complex matter full of variables, and for this there are very different methods and protocols of actions, and this is even more true for homes. Almost the protocol provide indication as an operational guide for the identification of the causes of disorder and for the suggestion of recommendation to solve them. The most critical moment is the definition of the spatial and temporal limit of the investigation for who lives in this space. Also, in this case, the EPA, USA EPA, developed an investigation model for residents and a small building built on the following basic step: initial approach, inspection, and evaluation and interpretation of results. The difficulties are aggravated by the shortcoming of the regulator apparatus both at the Europe and national level. The legislation is in fact to date unable both to define measures and verification method capable of identifying precise standard for living comfort and to identify precise reference that's all to be followed in design, construction, and production of materials and components. While it's possible to determine the harmful emission of individual materials in the laboratory, this data, when transferred to reality, become untranslatable due to the combination of factors that interact in the confined environment. It should be also added that the current strategy and regulation concerning the use of building materials are not only aimed to reducing the risk of indoor pollution, but at the ecological nature of materials in general. The use of regenerable or abundantly available raw materials, energy saving, harmful for workers, as well as recyclability and disposability without environmental risk. Is necessary, therefore, to undertake a new path to prevent, that is to pay renewed attention to the level of the project and project control, production of building materials, products and components, construction process and control of the same, management and maintenance of building. Indoor air quality can only be controlled through the development and implementation of standards and guidelines on air quality, standard on emission source, standard on ventilation, and standard on thermochrometric comfort. We today, caused the COVID emergence, have a great opportunity to call the project into question. Our eyes today are inadequate to new needs, not economic, but of the people. We must shift the focus to men and not to the efficient house that don't consume. I end with a joke. When I was a young researcher, I asked Professor Reggiani, who was responsible for indoor air quality at Istituto Superiore di Sanità, which was the best house. He replied, the rich man's house. Here we would avoid this and make sure that even the poorest house guarantees well-being and health. Thank you.
Thank you, Alberto. Thank you for your interesting speech that for sure give us opportunity to reflect about these very interesting topics, maybe our future research line. And also this speech highlight the needs for different and specific expertise. So the reason of this workshop. Have you any questions? when you speak, I have a curiosity. In your speech, I start thinking about the 110%. Now it's very popular in Italy. A lot of our colleagues are devoted, spend their time in designing and this kind of project to improve the energy efficiency of the house. What about the quality of the air into the house? For example, they told me that the fact to protect too much our houses from the exchange of temperature from outside to inside or vice versa can cause worse humidity, for example, in the house. They take into account some strategies about there are some constraints produced by the norm about this or not? They take into account only energy.
Only energy. When I speak with doctors, when I speak with doctors about this the problem of indoor air quality, they surprise because they say that architects are the innovation for architects are only the window with no senza spiferi, with no ventilation. Our house are concentrated just on energy and on indoor air quality. In fact, there are, you have to think, we die today for a problem for pathology.
That are caused
by pollution. Anche l'ultimo parlamentare europeo che è morto del PD, Sassoli, è morto per il morbo del legionario. E sono infezioni che prendi dagli impianti di condizionamento.
The problem in Italy, we had recently the die of politicians and the problem is that he died from Legionnaires disease. This is air pollution. That stay and lives into the air conditioning system. So died for this in 2020, 2022.
Okay.
Thank you very much, Roberto. Now the floor is to thank you. Now the floor is to Professor Revelle and the round table. So it's one of the keys of this workshop. Thank you, Gianmarco, to organize this very interesting topic. Thank you.
Okay, ladies and gentlemen, good morning. Welcome at this round table. I'm Gianmarco Revelle. I'm very happy to be here with you and to introduce very quickly this part of our Metrolive conference 2022. As you know, this roundtable is aimed to introduce and to discuss what's around the built environment in terms of future directions, future trends, and trying to figure out different point of views from a multidisciplinary point of view. I think this is very important because the built environment, the places where we spend our time are really affecting our health and well-being from many perspectives. And therefore, there are many running innovation and research projects that are trying to address how we can improve our living conditions in our built environment and how we can support people in this respect every day. So basically, the reason why we have put in place this terrific panel we have here, this marvelous panel with these colleagues and friends that I really would like to thank very much for being here with us, is that we tried to put together people that are expert in this field and that is trying to really tackle with the built environment from different perspectives. All of our colleagues that are involved here today are colleagues that are partnering with us in national or European projects, are expert with European projects and international cooperation, and are experts on the built environment from different perspectives. And that's why we just organized this roundtable in this way. We will have a first round of speeches of all the colleagues where they will present themselves, the institution they belong to, and one of their projects as an example of the activities that they are carrying out. And then I will try to animate a little bit of discussion on around the topics that will appear during the first round of presentations, so that we can really try to see how we can merge forces in the future to have an improvement of the conditions of the environment where we live, always taking into account that we are in a metrology-based conference. So on a conference that is starting from the metrology as the enabling technology to develop new functionalities, new services that are really the direction where our cities are going continuously in these years. So let me introduce our friends here first of all, and then I will give the floor to each of them to make some presentations. So the first one is Dr. Andre van Delft, director and founder of Demo Consultants. Andre was unfortunately able to join due to a force majeure. Andre should be online, however. Andre, if you're there.
Buongiorno.
Buongiorno. Hello.
Buongiorno a tutti.
Nice to see you. Now, I don't see you actually, but maybe we can just try to. Yeah.
Good morning, everybody.
Good morning, Andre. Nice to see you. Okay, then we should have had Professor Lucia Figuli from the Department of Security Management, Faculty of Security Engineering of University of Zilina, that unfortunately was here on the first day, but was unable to join the conference until the end, but she will replace very significantly from our colleagues, Professor Pasquale Da Ponte from University of Sannio, an honorary chair of our conference today. Then we have Professor Anna Laura Pisello, Associate Professor at Università degli Studi di Perugia. Anna Laura, thank you very much for being here. Even in your condition, I would like to stress that Anna Laura is pregnant, and that we are very happy for this. Then we have Professor Marco Arnesano, Associate Professor at Università eCampus, and colleagues with us at Università Politecnica delle Marche for many, many years and still strictly cooperating. Then I would like to thank Dr. Henk Herman Nepp from the Netherlands, expert e-health and coordinator digital care from Wilans in the Netherlands. Then Dr. Oscar Zanutto, Faber coordinator of ISRA. ISRA is Istituto per Servizi di Recovery e Assistenza agli Anziani in Treviso. Thank you, Oscar. And last but not least, Professor Sara Casaccia, Assistant Professor in our group at Università Politecnica delle Marche. So this is this great panel that I thank really once again for their presence here with us. And I would like to start, Andre, we start with you, actually. So we have all the slides in a single deck. So I will shift the slides for Andre, and then each of the speakers is invited to come here. But you don't have to change any kind of presentation. You just have to go on with the slides. Okay, so Andre, the floor is yours. I will try to recover the presentation somewhere. Okay. And can you see the slide, Andre?
Not yet. I do see a slide agenda. Yes, yes.
Here it is. So the floor is yours.
Thank you very much, Gianmarco. First of all, I would like to thank you for this invitation. Unfortunately, as you have said already, I cannot be present in real life. I did book my tickets already, but indeed to force majeure, I was not able to attend, which I, of course, really regret. However, if I must say anything about COVID, one of the positive things is that we are used to also participate online. So let's assume this as second best, that I can virtually join you in this roundtable. I've been asked to give a short introduction about myself, the company, and one of the projects. Let me start with introducing my name, André van Delft. I'm indeed director and founder of Demo Consultants, which is, yeah, you can continue, Gianmarco, to the next one indeed. Director of a small medium enterprise in Delft, close to the university and other research institutes. Our company is specialized in real estate information management. And we tend to work on this topic from 3 different disciplines, and it's also actually the internal organization of our company. So we have a software department, we have a consultancy department where we have consultants and inspectors or surveyors. So that's a lot about collecting and gathering data, one of the topics of today. And we have a research department. All those different disciplines are aimed on, again, real estate information management. And therefore, we have described our mission that we want to help our clients to make optimal choices when creating and managing real estate. If you could go to the next one. So what do we do? What do we provide for our clients, our customers? Answers basically to these questions that you can see on the sheet. So we answer the questions for our customers. Is your real estate, is it functional? Is it safe? Is it sustainability? Is it sustainable? Or is it properly maintained, energy efficient, financially healthy, or compliant? Actually, very simple questions, but with a lot of instrument products and services under the hood, as we call it, to come with those optimal solutions. By the way, this is a picture of Rotterdam, close to Delft, where we are based in the Netherlands. I've mentioned already that we are strongly working on research projects, and if you could go to the next slide. One of them is a project where we are very proud of to work on. It's called BIMspeed. And the consortium is consisting of 22 partners all over Europe. And I think, in my opinion, it's really a great mix also of types of organizations. So there are 8 SMEs included, 3 large industry, 2 research organizations, higher education institutes, universities in other words, 1 public body, and also 4 non-profit umbrella organizations. And in its essence, this BIMspeed project, it is not only about collecting and using data, but it is about creating what we call a high-speed highway for exchanging data related to this built environment. So it is BIMspeed. We are proposing a harmonized building information speedway for energy efficient renovation, or in other words, a complete ecosystem for tools that can work together. And if you could go to the last sheet of my introduction. This is, of course, a very detailed scheme that I will not explain in detail, but maybe just a couple of words about it. What you see in the center, in the focal point, that is really the core of the platform. It is about data storage and exchanging, and the circle around it. There are different components. First, how to collect data in many different ways. Secondly, how to structure it, convert it into BIM models, so all related geometrical and non-geometrical information about the buildings. Thirdly, it is about creating tools to do all kinds of analysis. Fourthly, to optimize them. And finally, if everything is analyzed, etc., how could you execute it in the real life world? So this ecosystem that we have been developing the past 3.5 years, that will be brought to the market in order to realize, well, mainly 3 objectives. The first one is to enable all stakeholders to adopt BIM to reduce the time of deep renovation projects by 30%. Secondly, to provide an affordable BIM cloud platform, tools and standardized procedures. And last but not least, of course, to create and implement renovation solutions with a guaranteed energy performance, because at the end of the day, that is what it's all about. So far, a short introduction of the company and one of the research projects. We do have many more, but maybe that will pop up later during this roundtable. So thank you for this opportunity to introduce myself, Gianmarco, and I'm really looking forward to hear the others' introductions and to participate in this meeting.
Thank you very much, Andre. Really interesting. We are very happy to be partnered with you in BIM Speed, which is a very interesting project where we are at the Università Politecnica del Marche working on integrating comfort measurement technologies. Yesterday we gave a presentation about this project. Okay, so the next one is going to be Professor Pasquale Da Ponte. Pasquale, you can come here. Actually, you're not the one in the picture, but
I'm sorry, I regret I'm not Lucia, of course. Okay. So I'm not Lucia, as you may understand. I'm Pasquale Da Ponte from the University of Sannio. Lucia regrets to not be here, but she's involved in another international meeting in Italy. If you meet her the first day, she's a Slovak professor of Žilina University. And she wished to inform you that Žilina is north of Bratislava, is a very beautiful and small Slovak town. Lucia has a particularity, is an expert in blasting, how to destroy something. So we are here to monitor and to create, but she's an expert. And she's an expert of the panel for reviewing NATO projects. I will speak of a project in which Lucia and I are involved, the HIRIS project, inspection, maintenance, security, pursued by innovative robots, enhanced data communication, infrastructure, digital twins. This is a project involved in a NATO Science for Peace and Security program. Some information in particular for young colleagues that are here in the room. This is a program of NATO supporting cooperation in the field of research. In particular, it is devoted to joint NATO countries, researchers from NATO countries with NATO friends. I don't know, as could be countries close to the border. In particular, this project is in cooperation with Morocco colleagues. This program supports some activities, advanced research workshops, advanced study institutes, and advanced training courses. I and Lucia next week will be in Moldova, in Chisinau, for an advancing training course for Moldovan colleagues from armed force and other public institutions in the use of drones for, of course, dual task and dual approach. If you want more information about this type of financial support, there is a web page of this NATO program where you may read how to apply. The next call is just for the end of May. Our project is a multi-year project. Is for 3 years long. Is about 400,000 euros. not so much, but it's good for cooperation. And the coordinator is Professor Gattulli, University of La Sapienza, Rome, and Dr. Amin Bendarma from Universiapolis International University, Agadir. If you want more information how to apply, of course, I can help you. The partners are the University of Sanioma University of Cassino, the Military University of Technology in Warsaw, University of Gilina, University in Agadir, Morocco, and of course La Sapienza. Why this project and why Lucia wished to inform you about this? Because the IRIS scope is to develop an innovative integrated system for inspection and monitoring of strategic structures. Strategic structure means bridge, dams, offshore construction, harbors, and this by using robots. It means UAV, unmanned system, underwater, water, and so on. In particular, we have a partner, University of Cassino, where there is a colleague, Enrico Ottaviano, that is developing robots for this type of investigation on infrastructure. Again, I think the most important part for this rent table is the second part, the creation of a model as digital twins. So not only to realize monitoring with hardware, but to realize a virtual environment, this is a parallel environment, in order to have under control the critical infrastructure. So the virtualization of the infrastructure. This is very important for me, for example, because I'm a professor of management. Why? Because we are moving from the analog to the digital world. It's fundamental. Think about an analog to digital converter. Now, the best on the market is probably 16, 18 bits. But virtualization means to work at 64 bits. It's a completely different approach. You are a virtual system that is work with a resolution of 64 bits. But the data that you are supplying this model are only 18, probably 16 bits. So there is a big difference. This is a gap. And I think that this is our work for people working in the analog to digital conversion. So how to increase the resolution coming from the analog world to digital one. And so to realize a digital twin that is as much as possible similar to the real, the analog system. Okay, for us is a challenge. And I hope this all the information that Lucia offered you. Thank you.
Thank you very much, Pasquale. Very interesting. We are all of us very much into digital twins and measurements for digital twins. But I think one good point here today is that we have to speak not too much technical, because, for example, these our colleagues are psychologists. So then we have to explain them what's about 16 or 64 bits difference when you converting from output from analog to digital. Next one is Anna Laura. Anna Laura, please.
Yes, I assume that these recommendations is also for me. So, okay, good morning and thanks again for inviting me. I'm Anna Laura Pisello, as Gianmarco has kindly introduced, and I'm Associate Professor of Building Physics in Perugia. And this was a slide for my affiliation. So as you can see, University of Perugia, at least in my opinion, is very much associated to urban Thailand, not because luckily Perugia is so heated, anthropogenically speaking, but because our group is historically very much focused on several perspectives, investigating urban heat from anthropogenic actions, so let's say human activities and solar trapping, so the influence that is played by the built environment configuration and physical properties on the local microclimate. And these opened the door to more or less probably the reason why Gianmarco decided to invite me, because I'm trying to face this challenge of mitigating urban Italians by, let's say, pursuing two kind of paths. The first path is related to the proposal of new and smart materials to, let's say, cover building skins and in general urban skins. So materials that are able to reflect or re-irradiate let's say, the heat radiation back to the source at least, or at least not to contribute to the urban overheating, and to test this material on a multi-scale. So starting from the material characterization in the lab up to the relatively larger scale of the urban canopy and urban canyon models. And how do we analyze the effect of these potential effective mitigation actions? Through a very much human-centric approach. That's why I put some figure on the left about the humans that are basically, in our experiments, wearing and carrying out several sensors for collecting geospatial data in the urban environments. Geospatial data are related, just to be, let's say, confidential, to air temperature, air pollution conditions, solar radiation, and somehow a reference of anthropogenic action and anthropogenic heat. And in our opinion, they are, let's say, they are the targets, so their well-being is the target of our investigation, but at the same time, they are also the vehicles for really getting data, primary and secondary data, in order to really have a kind of optimized decision-making system. So the idea is that that's why probably I got this project that is an ERC grant related to the proposal of new building skins and urban skins for urban Italian mitigation again. And the idea here is that typically classic cool materials are characterized by high solar reflectance in order not to get overheating during the course of a sunny day like this. But they typically re-emit and reflect over a Lambertian, let's say, in all the directions, and pretty somehow homogeneously within the spectrum. Our idea was to propose what is technically named as the radiative coolers, and especially selective radiative coolers, because they are able to re-emit the radiation back to the specific atmospheric window where the atmosphere is transparent. So imagine that you want to re-emit radiation, and of course, if you are in a room, you remit in all over the direction. So probably the radiation coming from this surface is re-emitted, the surface is somehow cooled, but then all the other surfaces are hotter. While the atmospheric window is a classic, let's say, window, imagine that you can re-emit preferentially within that window in order not to contribute to the urban heat balance, but to be able to re-emit outside the atmosphere, outer, let's say, to the cooler sky. That's why this kind of solution may somehow reach subambient temperature. The idea of the project is to start developing this skin, and we already started, and we coupled photoluminescence materials in order to achieve this selective re-emission. And the second part of the project, which is actually in parallel, because it can be seen not probably from a psychology point of view, but technically speaking, is somehow multidisciplinary, because it starts from the, let's say, basic chemistry investigation up to the large-scale eddy simulations. And so that's why the second two pillars of the project really concern the energy balance investigation at building and interbuilding scale. What we have done so far, we coupled already photoluminescence and fluorescence, not to be very technical, just to have a long-term behavior of what I mentioned before. And we are trying to input these materials into the weather forecast models. Who we are basically is a single PI project, but we aim at building a relatively large group thanks to the fact that in Italy we have relatively minor salaries. So with the same amount, we can hire some PhD students, postdoc, and senior researchers. And I wish to thank all of you for your attention.
Thank you very much, Anna Laura. Actually, I would really like to make again to you many compliments for these very important achievements. This ERC project, I think it's very, very promising, and it's you've been really very successful. In your slides, I see that you are affiliated at Princeton University. You have not mentioned this. I see the colleague Forrest from Princeton University over there. So if you want just to mention something about it, I think that would be appreciated.
Yeah. Princeton for us was a very important opportunity because we have a bilateral agreement that I established 3 years ago that fosters our collaboration, especially in terms of students exchanges and professor exchanges. And University of Perugia is part of an Italian universities network that own also residential spaces in New York City area. So New York City urban layout is for us, the most important lab where we experience all the technology that we develop. And Princeton itself will allow me, the collaboration with Professor Elie Buzaid first, will allow me to implement these materials physics into the urban canopy models. So we are going to make the scale up also together with them.
Great, thank you very much again. Marco, up to you.
Okay, as Gianmarco was saying, I'm professor in mechanical and thermal measurement. Actually, I'm professor now in the Italian university, which is called eCampus University, which is one of the largest, let's say, telematic and online university in Italy. We have 5 faculties. So in addition to engineering, we have also economics, law, letters, and humanities, and psychology. And the main headquarters of our university is in the north of Italy, is in Como, actually Novedrate near Como, and also other, let's say, other centers around Italy. Concerning the engineering, there are 3 main curricula, so industrial engineering, civil and environmental engineering, computer and automatic engineering. And we are also working actually, most of the research activity are performed by the Research Center on Energy, Environment, and Landscape, the CREAT, which is really involved in the national and international projects related to energy, sustainability, and living environment. Among the some of the activities that we have performed, I'm very glad to present this project, which is actually is an Italian project, the Next.com, under the PRIN program. Which is a project, the name is Next.com, because in this project we are trying to find a way to determine what will be the next future for the living environment. So the full title is Next Generation of Multiphysics and Multi-Domain Environmental Comfort Models, a Theory, Elaboration, Validation, Experiment. So what we want to do is to understand what are the limits of the actual way to measure and understand the perception of the environment from the human point of view. To do that, we are developing a set of procedures based on innovative measurement that it needs to be multi-domain, multi-sensorial, multi-physics, because human comfort is really such a complex quantity to be measured that involves several disciplines that we need to take into account if we want to create the next future for this kind of science and to better understand what is the comfort for user in the living environment. So starting from experimental procedures, we are developing new ways to investigate, to create deep knowledge about the relationship between the human and the environment. And using this new knowledge, we want to improve how the buildings are designed and controlled. How we are doing this? Actually, we are doing this thanks to the collaboration of the main partners of this project, which is run by 4 Italian universities. We have the Polytechnic of Torino, which is the coordinator of the project, eCampus University. We have the University of Perugia, so the colleague Anna Laura that was speaking before is working together. We are working together on this project, and we have also the University of Naples. How we can achieve this objective? as I said, it's really a complex matter. So we created this great facility, which is the next room, that was created by the colleagues from Perugia, and we collaborated on that, which is a really high controlled environment where we can change the indoor environment using both air and water system, lighting, acoustic, indoor air quality, and so on. So we can replicate different kind of scenarios, but in a controlled manner. So this is one of the really unique controlled environment around the world for doing this kind of experiment. And then what we did is, okay, we have a good environment, now we have to get the data. So we designed a very complex measurement system, which from one side has a set of sensors to measure all the environmental quantities, and there are really a lot of quantities to be measured, from the high velocity, air temperature, and so on, as you can see in this slide. And together with that, we are talking about comfort, we are talking about people. So if we are talking about people, we have also to include measurement about the person, which is in the indoor environment. So we integrated a set of wearable sensors to include also the physiological aspect of the problem. And then all these, let's say, sources of data were integrated together. You know, we are talking about different kind of data with different sample time, with different dimensions. So it's really multi-dimensional problem. So we developed a set of software and libraries so that we are able to synchronize all the data together, and then to clean, to process, and to derive really useful information that can be used to better analyze how the comfort and how the environment is perceived under certain conditions, so with a set of experiments that we are creating. Starting from this, we were able to create a large campaign. Actually, I think is one of the largest campaign in controlled environment, where we enrolled more than 50 subjects. We performed, I think during these days, we arrived to 300 tests. So we have this very, very big, large data set of data where we have environmental and physiological data. What we can do with that? Study a lot, because using all this data, we need to go really in detail about the statistical analysis, trying to find what are the most relevant, significant correlations between the data and the perception of the environment. So we started to this kind of detailed procedure, statistical analysis, and then we started to find really nice results that allows us now, and I hope in the future also, the research community and the industry to better understand how to control the environment, how to measure comfort using this kind of measurement to control the environment. So the first step that actually I presented yesterday also in a work during the conference, we started to select some of this data and to create some new models based on machine learnings. So now we have a set of models that using let's say a set of data coming from wearable sensors and physiological data. We are able to predict, to provide an accurate prediction of thermal sensation into the indoor environment. So using this model, now the next step and the future direction is to continue to create these kind of models and then to integrate them, for example, with the buildings energy simulation models, so to improve the design and trying to understand how comfort can impact also on the energy efficiency and how we can create, let's say a kind of harmony between the need of providing good environment and the need to do that in the most efficient way. And the second step is to deploy this kind of models also for the real life. So we want to go into the building using this kind of model to overcome the thermostat. We cannot control the building just with temperature in one point into the room. We have to talk about comfort. We have to talk about people. So we have to design HVAC systems that are human-centric, and we have to change how we control the environment. So we hope that this project is really capable to bring the base and to pave the way for the future. And we hope also, thanks also to this roundtable, to start to create synergies, because now we have a lot of tools. we have the way to create this knowledge, and we would like to create synergy with other kind of activities so that we can, let's say, put this knowledge in real life. Thanks a lot.
Thank you very much, Marco. Actually, with Marco, we have been brainstorming together for years about how to shift from energy efficiency to a human-centric approach in buildings. I think we've been quite successful in the years, even winning a kind of, I would say, 8, 9 Horizon 2020 projects in this area, FP7 before and Horizon 2020 and now Horizon Europe. So I'm very happy about the path we did, and I'm also happy. I'd just like to take the opportunity to say this, that we are now opening a spin-off company in this area that we are launching next week, and that we hope will be successful as well. So we are moving more and more towards the having the person at the center of the built environment, which is actually the trend. I think in particular after the pandemic, we are in an aging society. So that's why the next 3 guys speaking in our round table are more on this perspective. The next one is Hank. Hank, thank you very much again.
Yeah, thanks a lot, Gianmarco and the organization for inviting me. The hospitality is great here, so thanks for that. Yeah, I'm going to talk a little bit about digital long-term care, about Freelance, the organization that I work for. Yeah, I'm also affiliated with Eindhoven University of Technology. I have a background in general technology, a PhD. I'm a psychologist, but I really like technology. So I have some ideas about the 16 bits and the 64 bits because I like CD players, for example. It's something similar. So I like technology. Yeah, for the rest, I'm also a member of the board of the General Technology International Society. Yeah, Freelance. So Freelance is the National Expertise Center in the Netherlands on long-term care. I think we're the only one in the world, an independent organization, not for profit. And we have about 230 employees. Half of those employees are researchers, so also with a PhD, we have professors at Freelance. And knowledge sharing for free is really our business. So we have about 7 million visitors a year on our platforms. Well, for Italy, it might not be that much, but for the Netherlands, we have 70 million inhabitants. It's quite a lot. Yeah, 3 main themes. If you look at digital care, of course, we all know about the aging societies. We know about the shortages in personnel. It's really bad now in the Netherlands. So we have about 30,000 nurses, a lack of 30,000 nurses. If we don't change the way we work, the way we do it, we will have a shortage of 130,000 in 2030. So 3 main themes where we focus on. The one is co-design. So how do we do that well with seniors, with people with disabilities? Of course, if we design technologies, it should fit their needs, their wishes. In addition to that, and also I think good related to this conference, is value-based digital healthcare. So how we're going to measure the value, the added value of digital care. And then data-driven care. So all those digital care products and services, they gather a lot of data. And what are we going to do with that data? Also, for example, for prevention. So if you look at the people and the projects at Freelance, while we're in 43 national, international projects, quite a lot on digital care. Many of them are also national programs. So change management programs. I'm also involved in some of those. And we do a lot of European projects, mainly within the active and assisted living program. Currently, I'm coordinating 2 of them, which is HAL, and I will talk about it a little bit later, but also Guardian on social robotics. And I think there was a nice session yesterday on that, Pilaria, but also other AL projects. So a lot on robotics, sensor networks, etc. Yeah, we have about 40 colleagues working on digital care, which is a lot now. So when I started in 2014 at Freelance, we were with 4 people, and now with 40. So that will tell you something about the need for digital care. Yeah, we must learn faster together. If you look now in the Netherlands, also on policies, last week there was a huge campaign also from the Ministry of Health. So if we don't change the way we provide care in the Netherlands, about 1/3 of our income will go to care in the upcoming 15 years. So that's not sustainable anymore. So we need to change. And technology is one answer. It's not the answer. So yeah, as I said, end users are a critical success factor. We should support it by data, but also responsible innovation. So everything we do with respect to development, we should do that responsibly, because everything we design will have an outcome on people, and those outcomes can be positive or negative, and we should account for that. And of course, it should add value to the people's lives. We have a lot of models that we work with, and you see some below. I'm not going to dive into that, but if you want to know more about it, all that information is for free. Many of them also in English. Yeah, opportunities. So we said a lot about, well, let's say the aging society, etc., but it has a lot of opportunities. Of course, we can support independent living, quality of life. There's a huge silver economy now. Value-based care solutions, supporting informal carers' working life. That's what we also do with social robotics. And of course, enhance the work efficiency of formal carers. Yeah, and very important, increasing costs in care. So that's what we really focus on right now. Yeah, if we look at the work efficiency, what we see now in many of the programs and projects, the workload is everly increasing. Sometimes that also has to do with technology. So many of the devices that we are implementing right now, they use their own apps. Sometimes the app is only available for an iPhone, and then the other time the app is only available for Android. So we see that sometimes nurses have 3 different phones, walking around with 3 different phones. We should do something about that, and that was also one of the reasons why we started the HAL project. So that's a project I'm coordinating, but we also work with UNIFPM in that, and Irka from Italy, Jeff from Italy. We have Taiwanese partners. We have a lot of partners also from the Netherlands. And we even have partners who are in that project that don't get funding. So they think it's so interesting, we just be there. For example, the municipality of Aarhus from Denmark. So what you see here are a lot of products and services that have been validated, are on the market for long-term care. So you see social robotics, you see a senior tablet, sensor networks, IoT bedrooms, etc. Serious gaming, all to support people with dementia throughout the various stages of the dementia process. But what we want to do is that we combine all the data from those devices for prevention, but also for supporting the client journey. So that's what we're developing. In September this year, we will have a first prototype for usability testing. At the end of the year for alpha testing, and next year beta testing. And that will also be done in all these countries. So this is what we aim for. So an integrated dashboard in HAL where all the data comes in. It will work with like a traffic light system. So for example, when data from different sensors detect there might be something going on, for example, wandering, could be, for example, getting out of bed a lot, maybe well-being issues, etc. The combined data will work as a traffic light system. So a red is, of course, there's a huge deviation from normal, orange, a small deviation, and green, everything is okay. So that was my talk, and thanks a lot for listening.
Thank you very much, Henk. I think Henk opens this second part, as I was saying before, of the panel. We are moving in the direction of persons, and I think that when we move in this direction, technology has just to be a supporting and enabling elements to help people. Being people maybe formal or informal carers or fragile people, doesn't matter. Technology is just to support. So we as engineers has to understand the needs and translate them into solutions. That's very important. Thank you very much, Henk, again. Next one is always in the same field, Oscar.
Thank you very much, Gianmarco, and everyone for having us here and for such great organization of the event. So I'm Oscar Zanutto. I'm a psychologist at work and organization working for ISRA. ISRA is a public body organization based in Treviso in Veneto region, the northeast part of Italy. And we take care of older, so very closer to what Henk already told about. We host 900 older in 4 nursing homes. And we also have a co-housing where we have the opportunity to collaborate with Politecnico Università della Marche in several projects. So I'm here today to talk something about what we are doing in an H2020 project called Value Care. that belongs to a digital health transformation goal. This is important because we are here talking about measurement, so I try to, let's say, bridge the two fields about how measurement matter for care. Okay. So into Israel, we have an European department. So these are the main topics where we are working on, but are how we can digitalize health and care. We are trying to, let's say, catch up some countries like the Netherlands and the northern ones, because we know that in Italy, in the care sector, we are far away in terms of innovation. We're working a lot about inclusion and social innovation. You know, for example, loneliness is a big issue in our cities. Almost 40% of older people are living alone, okay, in average in Europe and in Western countries. So, for example, technology could be very relevant in supporting and connecting them. Active aging project and housing related. So, what is value care about? The story, briefly, is this. In 2006, Michael Porter in Harvard University in US, who is an economist, he discovered that if we deliver care based on, let's say, several performances, okay, where you pay the bill, you have an insurance, and you simply say, I don't know, I have broken my knee or something else, and you simply fix the situation. This system is not convenient, not for the insurance, not for the patient, but overall, this way doesn't produce outcomes that matter for patients. So he moved the approach towards creation of value, and the value is what mattered for us, okay? So the main question is asking people in their conditions what is relevant for themselves on one side, plus the experience of care. We think that experience of care is something that is a part or beside care, but is into care. You are all working about comfort almost, and I was just thinking that there's a comfort of care that is, let's say, a psychosocial dimension, not physical, also physical, but is related about, for example, Porter discovered that if you have to park a car half an hour walking away from the point of the meeting with the doctor, okay? And if you, when you are in the waiting room for the doctor, you need a bath and there's no bathroom closer and things like that. All such kind of experiences have an influence in your attitude towards care. So what matter? Experience, and the denominator is costs money always, okay? And so the issue is how we can measure outcomes, okay, that matter for specific disease. Could it be Parkinson's disease, dementia, or whatever, cancer, others? So Michael Porter created in Boston the ICHOM organization, is an international organization aimed to measure the outcome centered based for patients, okay? Creating a benchmark of evaluation regarding care. And here data, so measurement is relevant because those impacting care should be measured using the same metrics all around the world. For example, during COVID pandemic, they discovered that each country used several metrics in regarding how to track the COVID, let's say, expansion, okay? It seems impossible, but it was like this. So how we can adopt the same metrics also in such kind of situation. But back to value care. So we have 17 partners, how you can see, in 8 countries, okay? The leader is the Faculty of Medicine of Rotterdam, Erasmus Rotterdam University. As Israel, we are partner working on co-design and social engagement of user to create the value-based model. And so what we want to deliver is a personalized care for several kinds of diseases. So first, we deliver co-design sessions with patients, formal caregiver, informal caregivers, managers, and ICT managers in understanding how we could combine the integration of health and social care. It's still to be a very relevant issue, an open issue. We are not integrated. We are disintegrated between social and healthcare. So there are experiences to work on that and try to connect the parts. And the project is about how we could proceed on that. And the other part is a very technical part where we create chatbots, so virtual coach based on speech dialogues in an app. So the person set specific goal setting for brain cognitive serious games, you know, for working memory, semantic memory, episodic memory, or whatever. It's very funny because it seems that you are playing with and chatting with someone. Indeed, you are chatting with a chatbot. And we are just starting over with a pilot in 7 cities, also in Treviso, having 120 users plus 50 informal caregivers connected. And it's worth to say that the knowledge of a chatbot comes from Fondazione Bruno Kessler, who is one of the partners that has got an amazing protocol working on that. So the expected result is develop this final value care app solutions that will be also for free. You will download in the future. And we are trying to integrate services. This is the issue. And just to close regarding how to measure outcomes, the idea is that in our field, all the use of technology, the metrics, in my opinion, and thanks, Gianmarco, for having us, we need to move also doctors, psychologists, the health sector towards the metric, let's say, mindset. Because sometimes it seems that, let's say, quality could be, how can we say, self-referred, autoreferenziale, okay? But we need to be outcome-driven and not self-driven. So thank you very much for having us here. Thank you.
Thank you very much, Oscar. I think you touched a couple of very important points. One is about having a reference when you make a measurement, which is something that we have to expand also to subjective quantities. And for us, as scientists in the measurement field, this is a very interesting field. We will be back later in the second round of the table. And the second point is about the economic aspect. That is another dimension that we should always have in mind when we put together all these different views, because of course the built environment is going, and the cities in general are growing significantly in dimension and are concentrating a lot of the resources, money, and all the different energy, mobility, and so on, all the different kind of resources in the future more and more. So the economic aspects, of course, has to be always one of the multidisciplinary points that we have to keep into account. So we come to the last one, Sarah. Sarah, she's one of the pillars of our group. She's a biomedical engineer, so that's why we really are dealing with multidisciplinarity. And in our group, she's responsible for the health part. So Sarah, please.
Thank you, Gianmarco, for the presentation. And I'm really happy to be here. And I have to say the truth, I'm a little bit nervous about all this high-level talk of our friends. And I am assistant professor at the Department of Industrial Engineering and Mathematical Science of Università Politecnica delle Marche, and I'm part of the Mechanical and Thermal Measurement Group. For people that doesn't know where is Università Politecnica delle Marche, UNIPM is in the east coast of Italy, and our faculty is a university, as a mid-sized academic faculty, and composed by 5 faculty: engineering, medicine, economy, agriculture, and science. The main group, the core activities of our group is divided in 3 main pillars: industry, buildings, and health. And in particular, I'm working a lot in projects that are related to buildings and health. And in particular, for example, with Vilans, we are working in 3 running projects based on active and assisted living framework, but also I'm working a lot for well-being and comfort measurement, so also in projects related to that. Today, I want to bring my experience that I'm doing in this project with Gianmarco, but also with Riccardo, our colleague at Munich PM. This project is called Evita, is a European-Japanese project, and the main goal of Evita is to improve the quality of life and measure the well-being of aging people, developing a new kind of ICT network based on a virtual coach. And to do that, we are developing a new platform that is an interoperable platform based on sensors and coaches to provide virtual feedback to the user that is at home most of the time alone. The Evita consortium is composed by 22 partners, 12 from Europe and 10 from Japan. So we are also really happy to be in that consortium. It's a really high-level consortium. And the project was the only one that win the call for the Horizon Europe for the Horizon Europe program. What we want to provide in Evita is to have this kind of platform to measure the well-being of the user, of the aging people inside the living environment, using several kinds of sensors, because the measurement of well-being is a multi-domain measurement. And for that reason, we want to integrate in the platform several sensors that are user-related sensors, for example, smart rings, smart watches, smart pillow, and brain activity sensor, but also sensors that can measure quantities in the environment, like, for example, sensor to measure the air quality of the environment or to measure the activity of the user in the environment. All this information can be used to provide feedbacks to the user through coaches. And in specific in Evita, we are developing new kind of coaches. For example, we are using already in the market robot, like, for example, the Now robot, but we are developing in the framework of our project some new robot like Celeste, that is a spiritual coach, it's a spiritual robot, or the Rumato robot, that is a robot related to the cultural aspect of the Japanese people. And we are also using some new and innovative type of coaches like holograms. Our group is the work package leader of a work package that is related to the identification of the interoperability and standard guidelines to have all the sensors and coaches integrated in the same platform. But we are also developing new kind of sensors network. For example, we are developing this new type of sensor network that is to monitor the activity of the user in a multi-residence scenario. So when we have multiple people in the same environment, we can measure the activity of the user just without having too much sensor on the user, respecting the privacy, because we are using passive infrared sensor in the environment, just small tag that the user have to wear, for example, in the neck or in the pocket. We already published a publication last month that was published in Sensors. And another important measurement problem that we want to solve in Evita is the identification of the best sensor network that we have to use in the project, because in the project we are integrating a lot of sensors, but we don't want to use all these sensors for each user, of course, but we have to decide what kind of sensor we have to use based on the needs and the requirement of the user. And for that reason, we are developing this new use case configurator tool that is based on the input that are the user needs and requirement, and we are integrating some artificial intelligence algorithm, but also some logical and statistical analysis to identify what are the sensor network and the coaches that best fit the user needs. And of course, we need to identify what are the sensors based on also the result that we want to achieve. Thank you so much.
Sarah, my attention was taken from the spiritual robot. And maybe Sarah is very yoga-oriented girl, so probably she will use the spiritual robot in some session. Okay, so thank you very much. I think this was the easiest part. Now we go more into the open discussion. And once again, given the multidisciplinarity of our team, this is going to be challenging, but for sure it's going to be interesting. And then I would also maybe like to have some question from the audience. So let's see if there are any questions from the audience. Otherwise, we go with the second round of table. Okay, so I think we can go with the second round of table, maybe later. Okay, so Andre, are you still there?
Yes, and I'm looking at an empty chair, but I suppose you're standing next to it.
Yes, indeed.
But no worries, I'm still here.
Okay, so I think I would like to raise some discussion around, of course, the intersection between what we discussed and what we heard up to now, with the main topic of the conference. Of course, this is a Metro Live M conference, so the first word is Metro. I am professor in measurement science, and some of us here, 3 of us are professors, and many other colleagues are professors in measurement sciences. So I think that, of course, this conference started from brainstorming about how measured data, how data measured with sufficient quality, with reduced uncertainty, can be used to develop new services and new functionalities. So, as I said before, we as engineers, we have to translate needs from users into technical specifications. And this is why it has been always very interesting to be challenged from requirements that are coming from different perspectives, as we have heard today. Economic point of view, social point of view. When we're talking about sustainability, we have all the dimensions of sustainability. So not only the environmental one, but also the social and the economical ones. So all these fields has to be put together so that we can really achieve the goals that are expected from us. So what I would like to hear from each of the speakers now is a little bit what in the next years you would like to be measured, which data you would like to have to really be able to improve what you are currently doing, and what you would like the built environment to be in the perspective that is connected with your daily work or daily activities. So that's the first round of table. I think that the outcomes might be very interesting for all of us in this community, also to put the basis for new projects or also for the next edition of this very interesting conference. So, Andre, unfortunately, you are the first, so the most challenging is for you. What's your idea with respect to what I said? What you would like to see measured or analyzed? Which data you would like to have available in the next 10 years to really be able to improve what your company and what your research activities are carrying out currently?
Okay, I'll try to answer that briefly for you all. But maybe before explaining that, what I'm really aiming at for the company, what I really think is interesting also in this Congress is that, again, multidisciplinary approach. And we have been participating also in other projects where anthropologists, for example, were partners. And for me, as a technician, a building engineer, that is very important to realize the different perspectives. But before really answering questions from this user-centric approach, of course, it is very important to set a certain framework, to set a framework of data and tools that is reliable and sufficient to answer those questions. So if we make the difference, no, let me rephrase. When we are looking at data, we make the difference between static data and dynamic data. Data related to geometry and data related to non-geometrical information. And again, being a company that has customers in the built environment, both buildings and civil infrastructure, of course, there we have the use cases. So what we did notice in the past years that the digitalization that really sped up in terms of using BIM, etc., but mainly for new buildings. So for the existing built environment, it is important also to have the position on data related to those existing buildings or civil infrastructure. And so far, what we hear in the Netherlands at least, but what I also see in other European member states, that it's quite costly to obtain all that data. What we do see recently that there are different techniques, different tools, different devices that will make it feasible. And of course, you always have to look at a combined use case, or even better, a combined business case, because as mentioned before, economics or financial feasibility, that is key in all these kind of things. It's very good to obtain knowledge, to develop things, but if we really want to make the difference, we have to apply it in an active way in a built environment, in my opinion. So at first, it is very important to have a feasible approach, a feasible methodology and tools to really apply it for the built environment. And I think we are really at a breakthrough at this moment. Tools are becoming less expensive. And what we do see for our clients, for example, that they will start to give assignments to collect all the data for this built environment. So that is related to the static data. So all the relevant information of the assets, the buildings and the civil infrastructure. But on top of that, that is just obtaining data for, again, the framework. But what we are really interested in, of course, is not only to measure or to monitor, but maybe even to influence those environments. And that we can do by obtaining real-time data, as we have done, Gianmarco, for example, with a demonstration case in BIM Speed, where all kinds of sensors are provided by UniVPM, for example. So those will be, for me, the interesting challenges if we can upscale those kind of things. And of course, it is about quality, it is about exchanging data, but we should not forget that there's other barriers that we need to tackle. It is about privacy, again, economic feasibility, and also the willingness of consumers and professionals to use these techniques. I am quite positive that we will go towards that direction and that we will implement it. But to summarize in short, those are for me and for our company, well, the interesting things and that we would really like to aim at in the coming years. So firstly, obtain more data and get it more comprehensive, solid and quality wise, okay, about the built environment, but adding on that really all the dynamic measurements to not only measure, but again, to influence. And let me conclude with one example. One of the projects that we have been participating in, which is called MobiStyle. There, it was discovered by the University of Maastricht that if you differ the temperature, for example, along the day, and they called it mild cold, they found out that it really influenced the sensitivity for diabetes patients, if I might call it. And the improvement by just differing the temperature, that really helped patients to be more, how would I put it, more equipped to their diabetes. So it's not only about energy consumption or reduction, but there's really way more that you can influence in this way. So that is what we are looking forward to, and we have big hopes that we really can make a difference starting from science, but also really make the next step to really implement it in real society.
Thank you very much, Andre. You actually have been touching many of the points I would have liked to raise in the discussion. So really thank you very much. Very interesting. You're talking about static and dynamic data, influence, responsible innovation, which was mentioned by Henk as well before. But I think the one key point is the value of the data. For us as measurement scientists, I think we should really understand the value of the information we provide, not only from the technological point of view, but also from the ethics, from the economic point of view, and also from the societal point of view. So the value of the data measured is something that we should really understand and discuss about in the future. So thank you very much, Andre, again. Anna Laura, which is your view about it? What you would like to see measured in the next 10 years?
Okay, so thanks for this further opportunity of discussion. Probably I'm a bit biased about the interest we have for urban systems, but collecting the input that you gave us about the importance of analyzing the value of data, the economic value of urban mobility data related to the humans that are somehow moving is somehow estimated by Bloomberg statistics to be around 3% of the internal product, which is about 26 trillions, or probably, yes, by 2026. So roughly speaking, I do believe that this is our probably main goal, since the urban system at the moment already collects more than 65% of the global population. And there are other sociologists with whom we are collaborating that also tell us that the open data, so both primary and secondary data, let's say primary ones are those ones collected by humans freely, so they can be somehow unsecured and so on, with some risky stuff that we still have to handle. But secondary data are those ones which are already collected in key data sets that can be trained for validating algorithms and prediction models. So these all exploitable results are still, let's say, to me, weakly assessed, and they have a great potential. But this open data platform, especially in the urban layout for sociologists, represents a kind of foundation for good government activism. So in terms of economic and societal view, they are much more important, also because, of course, the environmental aspects is of interest for us, but these other two dimensions that you mentioned somehow can be fostered and run all together for a kind of new generation of good government activism and better awareness. So at least in the urban system, what we found is that the more you are aware about your environmental conditions and so on, the better you can react and you can adapt. So I do believe that is very much human-centric data. So those ones that you can really collect through wearable systems and very, microclimate-specific data are fundamental for understanding your quality of life, and to really know which is the level of risk you are exposed to, and to be really fundamental for training prediction models, because all this value is at the moment probably not much exploited. And in terms of health issues related to environmental parameters that we are interested in, I do believe it's a great potential to be disclosed.
Thank you very much, Anna Laura. Thanks also for the interesting data that you mentioned. I think that they give the quantity of some of the issue we are discussing. Professor Da Ponte, which is your view about it as professor in measurement, electrical measurements?
Okay, thank you for giving me the possibility to listen this contribution, because a short comment. I think that we are working as an engineer in measuring infrastructure to create a digital twin. But after this, your presentation, I think that we should, as engineers, include in this digital twin also some human factors, the wellness of the infrastructure. Because we have something virtual, but I don't know, not human. So how to introduce in these models some human aspect, psychological aspect, and so realize the twin also with the humans living in the environment. Probably this is a new challenge. Thank you.
Very interesting. Actually, I think I have heard for the first time about digital twins when talking about there were an experimentation for the Barcelona football players. The first time I heard about digital twins was about trying to have digital twins of these players during their training and during their matches. So actually, we are working on that. We are trying to really bring it to digital twins like wellness, like subjective impressions, and that's something that we will really challenge with in the next years. So thank you very much.
Gianmarco, just a short question. Sorry to interrupt, but could you please avoid the topic of soccer after last Wednesday?
Well, actually, okay. As you know, Andre, I'm not an expert in soccer, so actually I barely know what happened on Wednesday, but that's fine. I respect you.
Then I would like to congratulate you, all of you, with winning the European Conference League against Feyenoord Rotterdam. Congrats.
Yeah, Rome, yeah, for sure. We know. Okay, thank you. Marco.
Oh, well, a lot of faults. From one side, what I see, there are two main ways. What I see, from one side, there is the industry of constructions that require standards. On the other side, there is research. And these two ways sometimes getting in contact, sometimes no. Standards, industry requires standards. And for example, coming back to the comfort and well-being, research demonstrated all the limitations of actual standards. But we still have the same standards of 10 years ago. So because the industry requires to have some references. So if you want to assess a building, or you need to have some reference measurement to do, you have some KPIs, you have some figures to present. So what I see is that now we are looking at the comfort really with a very wide observation. So we are including a set of disciplines. So it's not just matter of measuring temperatures, humidity, or other things, but we have to include other measurements. We are including a lot of data. The second fact is that during the last 10 years, there has been a really increasing, let's call it entropy in the world of measurements, because we have seen that the IoT worlds and the sensors worlds is really increased. So we have billions and billions of devices sending data every moment, every second, every minute. And researchers are using this kind of data, trying to investigate the problem of, for example, the living environment. But at this moment, we need to remove a little bit of fog that is in this really big amount of data, because sometimes we get data from sources, unknown sources, or not standardized. We lack of references. We need what we can say a kind of standardized data curation. We need to have clean, curated data so that we can use them with the right confidence. Otherwise, the problem is that we are looking at the wrong references. And as you were saying before, for us, scientists in measurement, reference is the direction, is where we have to look, and is the term of comparison. So to guide the research, to be able to provide new standards for the future, we need, first of all, to help the research in how to move in this very large amount of data with the kind of data curation standardization. Just to make an example, there are a lot of wearable devices measuring using PPG, measuring some of the physiological parameters. And then what the producers give to us are some, let's say, API to get some data, but you don't know how the signal has been treated, how it has been corrected, what kind of processing has been done, what is the accuracy of the uncertainty of the sensors used, or also considering all the let's say all the sources of uncertainties that can come when you use these kind of devices in real life, when you are moving, when you are doing anything. So sometimes some researchers, maybe less expert in measurement science, just take that kind of data as good. It's a good data. It's provided by a producer, but actually it is not good data. So because it lacks a reference, you don't know how it has been treated. So this is one of the things that I think we should do as soon as possible, because I don't think that tomorrow the amount of data will be reduced. Actually, I think it will increase day by day. So we need to start as soon as possible to move toward this direction.
Thanks, Marco. Other very important points. The data that we are producing are dramatically increasing. There are some huge data available, like millions of data per second. So that's really increasing. And you touched some other very important point. One of those is standardization. For example, in the EVITA project that Sarah was mentioning before, further than studying spiritual robots, we are also trying to approach standardization of data and interoperability between Europe and Japan. And even though all of us was beginning thinking this to be an easy task, actually it is not, and there are a lot of things going on in this respect. So standardization, yes, is another. Also traceability, having common references in all these new quantities. For example, when we're talking about measuring comfort, we have the Giornata della Misurazione, which was focused on comfort measurements, which is the reference when we have to calibrate comfort measurements. So that's quite an interesting problems for us. Henk.
Yeah, thanks, Gianmarco. And well, first of all, everything that has been said, I agree on, so really good. But if you look at the long-term care field, I think I see for us 3 phases now in respect to data. The first one is similar to the HAL project. So as said, a lot of technologies and digital care solutions, they gather data, but there's hardly any integration. So I really hope for the upcoming, let's say, 4 or 5 years, that we try to integrate it, understand it, and indeed also from a human perspective know in respect to annotation what it means. So that would be a first step. The second phase is that I hear a lot of nice solutions here also in the home environment, the building environment, cities, etc. And of course a lot of data is gathered there too. And I can imagine that the combination can even predict, let's say, health problems or well-being even better. So, for example, temperature sensors are not included yet in a HAL solution. So that would be really interesting to get a better idea about, let's say, the person in respect to the digital twin. And if we talk about digital twins, what I would really like maybe in 10 years is that we can use that digital twin based on all that data and all those sensors also to value the impact of interventions. So for now, it's really difficult to measure, let's say, the impact of digital care on people. You need randomized controlled trials for that, huge numbers of people, and you hardly never know if it really has an effect on an individual. But if you have those digital twins, I hope we can predict, let's say, the impact of interventions and well-being far better if we have a better image based on the sensors and the data. So those 3 phases for the upcoming 10 years.
Great. The dimension of the problem is increasing, and the overall achievements, expected achievements are very important when we take into account all the different point of view that we mentioned before. Oscar.
Thank you, Gianmarco. Some comments from our perspective. So thinking about measurement, I think first, why have to measure something in care domain. And one good why is that if we look at 2050, the booming, growing population, it's a great challenge. So we will have around 33% of people over 65 years old around. Nowadays, for example, in Italy, we are closer in between 23, 25. In Treviso, we are 27, and in Trieste, 30% over 65 years old. So a good why is that we have a shrinking in resources, so we need to do something. And so the issue is what could we measure? And in my opinion, we need to combine clinical data, behavioral data, and the ones that colleagues talked before. So urban data, okay? So the join in between individual situation and community, let's say. Here, let me say that we have a big challenge that is GDPR and privacy, because we need to touch this phantom, let's say.
Finally.
Yes, among us, because if we want data and whatever, we need to feed the systems. And we need forecast. For example, the digital twinning and the other solutions that we talked about will be very helpful for doing forecast and looking forward in saying, okay, which are the early things of needs and so on. Secondly, I want to share with you this thought that is about the quality and reimbursement system. So maybe we need also measurement for have metrics for changing the reimbursement system, but should not be based on, let's say, simply performance, a piedi lista, come diciamo, but should be based on outcome, value, results. And thirdly, we need measurements to feed benchmark all around the world in saying, okay, I did like this worked, this not worked, but it's not based on single metrics, but common metrics. So about care, we need to have quite the same, or at least a common denominator where we can compare the Dutch and Italian care, for example, or all the European and worldwide care systems. Because as person, we are the same, the diseases are the same, okay? But the context change, and we need to work on common approaches. Thank you.
Thank you, Oscar. Yes, I think the reference framework where arriving to big data from many different sources is defined and is treated in respect of the GDPR is, of course, one of the big challenges in the future. When we bring in feed, for example, all the health-related data, then it becomes more and more complicated. So maybe Sarah wants to comment on that, indeed.
Yes, I want just to talk a little bit about what all the others said before, like, for example, human-centric approach, comfort, well-being. I want to just to discuss a little bit with all of you about, for example, if you have to measure the well-being of aging people with some disease, we can, for example, disease like dementia, Parkinson's disease, cancer problem, or cardiovascular problem, we can measure, for example, physiological parameters and extract information of well-being. For example, what about healthy aging people? What are the measures that we have to extract from healthy aging people? For sure, they don't want to know nothing about blood pressure or heart rate variability, but they want to know other aspects. So we have to also to consider that, for example, the well-being as a really multi-domain aspect, also in relation to, for example, to comfort, physiological state. And I think that we have also to understand what are all the domain of the well-being. Like, for example, if I'm thinking at healthy aging people, we are also always to consider economic status or the social aspect of the user. And we have to integrate all these parameters in the measurement of well-being. So I think that this point could be really nice for thinking about the future of this measurement.
Yeah, cultural aspects as well are one key point. And I think that even we have not had time to mention, but artificial intelligence as well might be a very important key point. When we have all this data, then we can really try to get on that. Is there any question? Of course. I was seeing before Francesco telling me, but that's fine, of course. Please. Yes, thank you very much. I mean, that's a very broad topic, of course, but the social role of technology and of measurement itself has to be always kept into account. When Hank before was talking about responsible innovation, is also dealing with that. Francesco, we are done. So let me take the opportunity to thanks really warmly all the speakers for being here. There was another question. Okay, it's not my fault, Francesco. Great. Great. Thank you very much for the contribution. Okay, so ladies and gentlemen, let me really warmly thanks again all the speakers that have joined today, all the friends. Thanks, Andre, from the Netherlands. Even sorry that you will not be joining us for the lunch last night for the dinner, but also let me thank the organizing committee, Francesco, and all the others here. I think that this is being a very, very good first edition of this conference. Thank you very much. Ciao Andre, let's keep in touch soon.
Bye bye, alla prossima volta.
Alla prossima volta.
So we have Giovanni Guiandolo, the presenter, okay? And if I'm not wrong, Ilias Koulalis, is that correct? Thank you. And Tiziana, I'm pretty sure that we will not be able to end our session at 10 minutes past 1. We have, you know that we have 20 minutes for the presentation, 15 minutes for the presentation itself, and 5 minutes for questions. I will kindly ask you maybe to shorten a little some slides, just to try to catch up with the scheduled time. We'll see how it goes. We call Francesco. Okay, so we had the Go by Francesco. Thank you everybody for being here, for joining this general session, part 2 of the general session. Just in time. My name is Nicola Pasquino, and together with Marco Arnesano, we will be chairing this session. And the first presenter, this is a very unspecific session, I would say, unfocused session. Maybe the only thing that we share is the quite long titles of the presentations. Jokes aside, let me introduce the first presenter, Giovanni Guiandolo from University of Messina. The paper he's going to present is titled IoT-Powered Detection and Alarming System for Hazardous Gases in Domestic Environment. I will tell you when 5 minutes are left, if you agree, okay? Thank you.
Okay, I'm sorry. So this research activity is focused on the design and implementation of low-cost platform, actually measurement system aimed at air quality monitoring in a domestic environment. The goal is to design a measurement system made by commercial components, low-cost components that are easily available on the market. And in particular, it is a combination of a development board with some sensors that are able to detect the presence of possible hazardous gas in the environment. This presentation is organized as follows. First of all, I will provide a definition of what a smart home is. Later, I will list all the hazardous gas that we can find inside the domestic environment, and the proposed prototype will be presented with its test on 2 different scenarios. And later, conclusions will be discussed. A smart home can be defined as an home, or more in general, a residential environment, where a set of sensors, devices, and technologies provides innovative functionalities with the aim to improve the living comfort and the living condition, and to improve also the resource management of the building. So, for example, in a smart home, we can find smart thermostats that are able to control and monitor the temperature inside the building in a smart and efficient way, For example, considering the outdoor temperature or sometimes also provide weather forecast. This is very important since these systems allow to reduce the power consumption as well as to minimize the greenhouse emissions. A smart lighting system can be also found inside a smart home. It is also able to improve the living comfort and reduce the power consumption. Also security systems are very important in a smart home. We can consider both, they are able to detect possible intrusions, and in a smart home with intrusions, I mean physical intrusions as well as cyber intrusions, so cyber attacks, and this is a very important topic if we speak about smart homes. Here in this list, I included also air quality monitors, since this is the topic of this research activity. So why it is important to monitor the air quality inside a house? It is important because every day a lot of hazardous gases are produced inside our homes. For example, volatile organic compounds coming from the chemical products that we every day use for cleaning purposes. So, for example, in the bathroom or in the kitchen. They affect the kidneys and the nervous system and can cause cancer. Then there is the carbon monoxide and the nitrogen dioxide. They are produced, for example, by cars in the garage or in the kitchen. The carbon monoxide, in particular, it causes headaches and nausea at low concentrations. At higher concentration, it is fatal for a human being. The nitrogen dioxide is responsible of respiratory infections. Also, the radon is a very important hazardous gas that is present in our homes. It comes from the walls, from the ground, and it is able to penetrate inside our rooms. It is a radioactive gas, and according to some studies, it is considered the second cause of lung cancer just after the cigarette smoke. Smoke that I included also in this slide. Here, I mean the cigarette smoke, but also smoke from possible fires inside the homes, and smoke from, for example, the fireplace. Also, humidity is very important inside an home. In fact, high levels of relative humidities can produce a growth of bacteria, fungi, and molds that can affect the immune systems and can bring respiratory infections, allergies, and asthma. So, for this reason, even if the air quality monitoring is not mandatory, sometimes it is strongly recommended inside our homes. And this is the main goal of this research activity. So the development of an air quality monitoring system made by different modules that are assembled together in order to produce a low cost and an easily expandable system. This prototype is based on the Linkit One development board produced by Seed Studio in collaboration with MediaTek, and it is combined with different sensors and other accessories, and it is also equipped with a communication unit made by Wi-Fi, Bluetooth, and GSM modules to allow the remote connection, the remote monitoring of the system. In this first prototype developed, we included 3 sensors: a smoke sensor, the MQ2 sensor, the carbon monoxide gas sensor, the MQ9, and a temperature and relative humidity sensor, the SHT31. The first 2 sensors are metal oxide factor gas sensors, and their working principle is well described in the literature. They are based on chemical reactions between the target gas and the surface of the sensing material, and these chemical reactions affect the electrical properties of the sensing material, for example, the conductivity. So we can consider this kind of gas sensors as resistors whose resistance value is strictly related with the target gas concentration. So sometimes, instead of considering the resistance of this sensor as an output signal, it is considered the resistance of these sensors normalized with respect to its resistance in clean air. In this work, for all these sensors, we used the calibration informations that are reported on the components data sheets. For temperature and relative humidity measurements, we used the SHT31 sensor that, for considering our application, it is characterized by a relatively wide measurement range in terms of both temperature and relative humidity, and relatively low measurement uncertainty. 0.3 degrees Celsius for temperature measurements and 2% of relative humidity for relative humidity measurements. Then we included, besides sensors, also additional modules, additional accessories to these systems. For example, a buzzer module in order to generate an acoustic alarm in case of danger, an RGB LED that we used as status LED, and a user button for the sensors management. And moreover, we included a battery as an additional power source in combination with the USB cable. This is a picture of the final prototype that was assembled into a plastic box. We can see the gas sensors, the temperature and relative humidity sensors, the buzzer, the RGB LED, the user button, and then here inside in image B, the Linkit One board with the group-based shield and the antennas connected to it. A web app was developed for the remote control of this device, and for this web app we used the UBDOTS platform. This platform offers several features for IoT-oriented applications. For example, it is possible to collect data from sensors and store them on a remote server, create events, and so on. All these features and all these services can be managed through the UBDOTS API. That in our case, the Linkit One board used the UBDOTS API for the communication. Besides the web app, it is possible also to install an Android app and control the system remotely using the smartphone. Our prototype was tested considering two different scenarios. In the first scenario, we are in a safe condition. And in particular, the carbon monoxide level and the smoke level are below a predefined threshold that was set on the microcontroller. In this case, the LED is green and the buzzer is off. If the carbon monoxide level or the smoke level are above a certain threshold, so the Linkit One is able to send an SMS message to a predefined telephone number, for example, to an end user. And if an internet connection is available, UBDOTS is able to send an email containing all the information coming from the sensors connected to the Linkit One board. Moreover, an alarm is generated through the buzzer module, and RGB LED is red. The second scenario is when from an alarm condition we go through a safe condition. So at this stage, the carbon monoxide level and the smoke levels are both below the predefined thresholds. Also in this case, the Linkit one sends an SMS message to the end user in order to inform him that the alarm condition is gone. The buzzer is off and the LED is once again green. So in this presentation, I presented an IoT-enabled detection and alarming system I made for air quality monitoring inside and inside the living environment. The system is modular, can be easily expanded using additional modules that are easily available on the market. And moreover, the system is easily upgradable in terms of both hardware and software. And it is possible, for example, to add additional modules, additional components and sensors. And in fact, we are planning to use this platform considering more components and sensors in order to expand the capabilities of this system. So thank you for your attention. I am available for possible questions.
Thank you for your presentation. I would ask people if you have any questions or comments for the presenter. None.
Okay.
Ask one.
Just a curiosity about the gas sensor used, because you were showing it's based on resistance measurement. What about the potential drift due to temperature? And if you experimented some way the potential drift of this kind of sensor during the time that can provide problems with the threshold that you selected?
Yes, for sure, there is a drift related to temperature change and relative humidity changes as well. Actually, this is the reason why in this project we included also a temperature and relative humidity sensor. However, at this stage, it is not still used, but we are planning to use it in order to correct the response from the sensors. And on the sensors datasheet, there is also how the response of these sensors is affected by temperature and relative humidity values. So it is possible to have a compensation on these environmental changes. Thank you.
Thank you once again.
So go to the next work of this session, and the title of the next contribution is an early warning system for fire spreading by monitoring simple climate conditions and combining cellular automata with the digital twins. The talk is given by, is presented by Ilias Koulalis, right? Thanks. From Greece, so from the Information Technologies Institute.
I'm coming from the Information Technology Institute in CERT in Thessaloniki, and I'm going to present this work developed with my team. The aim of this work is to provide a simplified version of a digital twin, which purpose is to monitor climate conditions of interior building and to provide early warnings and decision support. Actually, based on sensor data and information coming from IoT and other information, and also the use of beams. Nowadays, there are in the literature several systems that are proposed in order to provide information about the safety, the indoor safety. But when it comes to safety and fire outbreaks, besides of detecting fire accidents, another important factor is also to predict fire dispersion and recommend for actions to early prevent the development of unwanted consequences, such as, for example, the uncontrolled dispersion of a fire or the blocking of a fire exit. So, okay, towards to this, nowadays there is a this approach that is called digital twins. But actually, what is a digital twin? A digital twin is a virtual representation of a real-life object or device that learns and updates itself from the sensing sources, and also it integrates intelligence in order to, based on the information coming from data and sensors, to be able to recalibrate itself based on its servicing and its geometric properties and etc. And this intelligence usually is built on top of the data collected in the form of data analytics, machine learning, or physics, and resulting in capabilities like predictive modeling, optimization, and early warning systems. And in this work, the approach we followed is presented here in this conceptual architectural schema, and actually from the core to outwards, if we follow it, first we build a sensing platform, then for the monitoring visualization tool, a GUI, in order to present the sensor data, then the early warning, the provision of early warnings based on the readings coming from the sensors, and then a modeling for the prediction of the fire expansion based on space geometry of the physical space geometry, and lastly, in the last layer, the decision support based on the sensor matrix and the modeling followed. Also, as you understand, this sequence will govern also my presentation, starting with the sensing platform. Okay, very simplistic approach we had here, just in order to use it as a proof of concept for our method. We used a simple DHT11 sensor for sensing the temperature and the humidity in a physical space. The sensor was paired with an Arduino Uno microcontroller, and actually the measurements received by the sensor were calculated and translated to temperature and humidity values, and then were forwarded via a serial port to a server for the rest of the processing. The next step, the visualization of the sensing data. For that, we used the processing graphical library for three main reasons. One, for simplicity, because it's an open source graphical interface, and also it uses a Java environment, Java language, which was convenient at the moment. Also, it uses a sketchbook format, which was ideal for the pairing to Arduino, and also finally because it provides us other simplification and added classes and analyzes to mathematical functions and operations that were used later on for the modeling. Regarding the GUI that we prepared, it is divided in two sides. The right side of the GUI serves as a command and control interface, where all the indications of the sensing are presented, and also on top there are two buttons in order to start and end the user to start and end the simulation. And on the left part, we present a simple topology of the actual space of the top view of the building floor, and just to indicate regarding the topology, because later on it will be used for the modeling. The gray part represents the walls and inaccessible areas. The black section of the topology represents the free areas that the fire can expand. The green spots represent the position of fire extinguishers that we assume that existing in order to later on to build and to base our decision support. And the blue area, the blue spot represent the position of the sensor. So for the early warning, the first intelligence step, let's say, we just used a simple thresholding rule. A simple rule was implemented when the temperature was exceeding a specific threshold in combination. It should have also, let me check. Okay, so as you can see here, there is a visualization when the temperature raises and the humidity remain low. There is a threshold that when exceeded, the blue sensor spot becomes yellow to indicate the sensor position that exceeded the threshold. And also, it's not to be shown very well here. A message appears at the bottom to warn the operator about a possible fire accident, and that way it reports somehow it notifies the operator about something is wrong. So now for the modeling of the fire dispersion, we were based on cellular automata, which is an elegant parallel computation tool for physical systems introduced by von Neumann and Konrad Zuse. And as it happens on physical systems, the principle that follows is that they use the same clock, the same timer. So for each cell, the situation in every step changes simultaneously by creating by that way a synchronous system. The building block of a cellular automata is the cell, of course, where its states is governed by a set of rules, and also is guided by the state of the neighborhood, the neighbor cells, and these cells, all these cells, are following the same set of rules, and are arranged in a lattice in order to create the physical space. There are several variations for this cellular automata. In our modeling, what we used was the Moore variation, and the state of each cell was defined by the equation on top, where the cell type can acquire 4 specific values based on the topology, and the fire value is represented here, and actually it's a variation of the district diffusion equation for cellular automata, discrete diffusion equation. And actually this was the algorithm that we used for the modeling. So yes, I'm finishing. So for the decision support, what happening is that each time the predicted expansion of fire, when it reaches a location, give me a moment. When it reaches a location of a sensor, a fire extinguisher, then it presents a message to the operator again in order to notify him how to react and what to do. And more or less, okay, this is the presentation. And to conclude, it is what we propose is a simplified version of a digital twin. Digital twin combined with a cellular automata, which is a powerful modeling tool that requires low consumption and low resources, and without requiring any large data as the learning systems do. And okay, in a nutshell, what we propose is a holistic approach integrating from sensor data readings to early warnings to dynamic modeling and decision support, and by that way we draw a pathway for future developments and future implementations.
Thank you. Thank you for the presentation. Are there any questions? No questions.
Yes.
Yeah.
Typical processing times of such a sensor and system.
Actually, the approach is not for sensors or for systems. Actually, okay, as an institute of computer science, we've done a lot of work on different steps of the steps that presented for sensor, for sensing, for data fusion, for early warnings. What we present here is that we put all these elements together in order to start building in an early stage yet a digital twin, and later on to integrate other intelligent things with a sensor. Okay, we're not people of hardware, but we know about fusing sensors or applying machine learning, for example, for early warnings, or maybe for the topology, computer vision capabilities in order to be able either for top views to generate the digital representation automatically, or even photogrammetry for 3D representations. And okay, our aim, our goal is to build on that and to evolve to a system more pragmatic, more realistic.
Thank you.
Thanks. So we can move on with the session. Actually, we've seen these first two works were about using IoT data. So it's also important to think about the infrastructure and how we transmit this data. And during the last years, we've seen an increasing use of cellular data, LTE, so 4G, 5G. It's important, so for the next two works that we are going to present in this session, to understand how to characterize the impact that this technology, so the exposure that we have to this kind of fields can have, and how maybe we can limit this kind of exposure. So the next work is entitled How to Characterize Power Lock Systems for Limiting Exposure to Electromagnetic Radiation Generated by 5G MAMIMO systems. I think MAMIMO is correct, as I said?
Massive MIMO.
Okay, perfect. And the work is presented by our colleagues Nicola Pasquino from University of Naples.
Thank you, Marco, for the presentation. The results I'm going to present today are the result. Any problem with the mic? No, everything is okay. Results of a fruitful collaboration with the two regional agencies for environmental protection, namely the regional agency of Piemonte and Lazio, together with one of the mobile providers in Italy, Vodafone Italia, and the University of Naples. Let me first give you a brief outline of the talk. I will introduce the research through the motivations which lay behind the research that we took on. I will show you how the power lock system works through a working example. Then the methodology that we propose will be given and will be proposed to you. And let me state the aim of such methodology, which is to characterize the power lock so that we do limit exposure, so that the power lock system limits exposure without limiting the coverage of the mobile system. Then I will present the measurement setup, the signal, the measurement chain, the measured quantities, and then the experimental results together with some conclusions and the ongoing research. First of all, the introduction. The main difference between the traditional and I would say the previous generation mobile system and the actual and the future mobile system antennas is that with traditional antennas, you have power that is radiated throughout a wide angular range so that the whole area, all the users, even not the active users within a cell, are radiated by some power. With new generation antennas, with smart antennas, you radiate power only to the directions where power is needed. So that if someone is here, for example, and not using the cell phone, and the cell phone is typically in a standby mode, there will be no beam toward its direction. So the issue is that beams will change both in time, they will be active or they will be off, and in space, they will follow users or groups of users during time. What does that mean? It means that the time-varying behavior and the spatial multiplexing of such new generation of antennas will result in no proportionality between the total radiated power and isotropically radiated power in the user direction. There is no chance of correctly knowing the power in one direction once that I know what is the direction, what is the power that is being given to the antenna. This means that the potential exposure, the maximum exposure that a user can be exposed to must be assessed through a statistical approach, relying on both space and time distribution. And there are two international standards that tell you how to do that. Simulations are based on the actual maximum transmitted power, which is the 95 percentile of the radiated power, not on the nominal power that feeds the antenna. Within the IEC standard, there's some specific sections. There are some specific sections that tell you how to monitor and control the radiated power so that the average transmitted power over a reference time interval keeps below the actual maximum transmitted power. And this is the power lock system. The power lock system must, first of all, monitor the transmitted power, usually at a few kilohertz rate. Then it must calculate the current average power. Since there's a reference time interval, which is usually in Italy 6 minutes, according to the European guidelines, which have been updated in February 2020, the time interval is 30 minutes. So you choose the reference time interval, and then you can calculate the current average power. Then, when the power lock system realizes, and that's the main point, when it realizes that the maximum power is being approached, then it must activate so to limit the transmitted power in order to have the average transmitted power over the reference interval be compliant with the limits. Well, I should say will be below the value that makes the exposure to electromagnetic field compliant with the limits. So the main issue here is how to establish when the maximum power must be limited so that the overall average will be compliant with the limits. Let's see how a power lock, in action. You can see that at the beginning, the uncontrolled and controlled power are basically the same. So there is no control over power because the average power is below the value that will result in the maximum allowed exposure value. Once the required power overcomes and goes up and reaches some value, the power lock system realizes that the average power is increasing. So at a certain time, it will say, okay, that's enough. I must limit the transmitted power so that the average power can stay below. So the uncontrolled power would be here, but instead, the power lock limits the power that it can be transmitted. When and how the power lock limits power remains to the vendor. That's a point because this requires that all the procedure and the methodology uses a kind of black box approach. We don't know how, we don't know when, we don't know the logic of the power lock system. And in a sense, our methodology has been designed having this constraint, which makes our methodology quite general, because we don't need to know how the power lock works. The aim of the methodology is to test the power lock so that we can assess its effective limitation of power, although the coverage area remains unaffected, which means that some signals must be transmitted at a higher power, but the traffic signals, the signals that are required by the user, remains at a level such that there is no overexposure to electromagnetic fields. We tested our power lock under different configurations. First, we start with the power lock off with a specific value of the average power, the maximum power that is radiated by the antenna. Then we increase the power so that we can increase the coverage area, but we have to make sure then that there is no increase in the exposure. There may be some preliminary knowledge, but it's not required, about the way, about how the power lock reduces power. It may reduce the number of resource blocks assigned to the user, or it may reduce the power because it physically reduces the power that are given to the traffic channel. The methodology basically turns into a procedure, and for each step of the procedure, there will be a specific test that must be run. Preliminarily, we need to force the maximum downlink capacity because we need to work with as constant as possible transmitted powers. So at the beginning, we have to use, first of all, we have to turn on a specific device. We have to force maximum downlink occupation. Usually that's done with the UDP download, which forces the full channel. Then we fix P0. This goes through some iterations so that at the end of this iterative approach, we can realize the maximum average power so that we have the maximum allowed exposure. Then we increase the power by some amount, yet keeping the power lock off. And then we activate and we validate the power lock off. We will see that the instantaneous power will decrease, yet the broadcast channel, which are the channel for signaling, are still held at P plus delta P, the increased value. The measurement setup, line of sight propagation, this is a typical 5G system, 80 megahertz, 6 SSB per single burst with TDD duplexing. The measurement setup, we measured at two different sides. At the transmission side, we measured the resource blocks and the instantaneous power with different frequencies. At the measurement side, at the receiving side, the channel power and the field strengths were both measures, of course, with different measurement chains. These are some configurations for both the channel power and field strength measurements. And let me show the experimental results. I told you 3 different tests. These are the 3 different time frames related to each test. We first fix P0, so to determine the value which will result in the maximum allowed average exposure. We don't have time to go deep into these variations. This is something internal that we had to investigate with the vendor of the power lock system, and I should say the smart antenna system. Then in the second test, we increase Pmax by, for example, 5 dB. And you can see that the power has indeed increased by 5 dB. Let me show you that even when we don't have traffic, we have an increase here of power because the signaling blocks are active. Finally, we activate the power lock. At the beginning of the activation, the instantaneous power goes up to the maximum power. Pmax has increased by 5 dB. At the beginning, we can use the maximum power. But since with the maximum power, P0 plus delta P, the average field would be too high and would go over the maximum allowed average field, then the power lock activates and it pushes the power down to the value that will result in the compliance with the exposure limits. Short summary: first step, we determine P0, which is the average power. P0 is related to the maximum power that can be transmitted because of the time division duplexing that characterizes the 5G system. Then we have the increase, 5 dB, and then with the activation of the power lock, we have the maximum power, but the average power goes down to the average power that was before the increase of the maximum power. The impact on broadcast channels: at the beginning, we have one specific value after determining the value of P0. Then, second step, we increase by delta P, and as you can see, the traffic channels, which are these channels, and the broadcast channels, which give the coverage area, they both increase. When we apply the limitation of the power lock, the broadcast channels would stay at the high level, while the traffic channels, which determine the exposure, will go down to the maximum allowed value. If you don't trust time domain and zero span measures, please have a look at vector domain, the demodulation on some specific channels. You can see that with the power lock off, you have the maximum power is here. This is for the synchronization channel. When the power lock is on, the broadcast channel will increase. You don't see 5 dBs because of the measurement uncertainty, but 5 dB, if you include the measurement uncertainty, is certainly compatible with the difference between the two average values. So let me go to the conclusion in 30 seconds. We propose a way to characterize the functionality of the power lock systems. The methodology has proven effective in demonstrating the correct operation of the power lock, and we proudly announce that the methodology has been successfully submitted and accepted for inclusion in future edition of the reference standard for the in situ validation of such systems. And the ongoing research is to characterize 3D power lock system. The 3D power lock systems are systems that act on a per beam basis. They can apply a specific limitation to each beam, not the same limitation to the entire set of beams. That will conclude my presentation. Thank you for being here, and of course I'm here to answer your questions or to reply to your comments. Thanks again.
Thank you, Nicola. Are there any questions? Please.
Usually in electromagnetic field measurements, we don't use percent, we use dBs. Usually the measurement chain, if you add up all the contributions, you easily end up with 2 or 3 dBs. Well, it's actually not in this case. Well, in this case, we just wanted to make sure that the control channels had the increase that we applied to the maximum power. We applied 5 dB increase in the power. You don't see 5 dB. Here is less than 72, minus 72. With the increase, the nominal value is slightly larger than minus 70 dBm. So the difference is almost slightly larger than 2 dB. But if you include the uncertainty, which is almost 2 dB here, 1.5, should be 1.3 dB, then in the end, you see that the minimum value here and the maximum value here are within the 5 dB, include the 5 dB increase in the maximum power. So it's not a problem. It's not here. There's no feedback. I mean, there's no control over the power. You just locally increase or remotely you increase the power, but that's it. Just that's simply a way to say, let's make sure, of course, including the uncertainty, that the increase that we have given to the maximum power only, together with the limitation included by the power lock, only affects the broadcast channel, the traffic channel, not the broadcast channel. You would say that it affects because you see only a nominal difference of about 2 dB. But together with the uncertainty, you can say, no, maybe, because of the uncertainty, you must say maybe I did increase by 5 dB. And that's something that you see here. If you see here, this is the difference, the distance between the SSB and the traffic is indeed 5 dB. But this is in time domain. The other one is the demodulation of a specific traffic channel and a specific channel within the frame of the synchronization burst. Right. Thank you.
Other questions? I have just a curiosity. Yeah, but just because I'm not expert of this field. I was wondering, what is the trigger used to activate a certain beam in a zone? You said at the beginning with these new antennas, you know, if there are devices, the beam is activated, so you increase the power and then you have that. And if there is no device, you're not. So what is used to understand it?
With this beam, you have an exchange of information between the mobile users and the base transmitting station. So during that beam sweeping, you realize when and where you have some users, and thanks to that signaling, you decide which beam must be activated and how the beam must move so to follow the user. Thank you.
Okay. So if there are no other questions, I think we can move to the last work. Do you want to present the last work?
Sure.
Or
Thank you, Marco. The last paper will be presented by Tiziana Cassano, who is with the Regional Agency for Environmental Protection of Puglia. The title of the paper, the contribution, is The Assessment of Population Exposure to Electromagnetic Fields Due to Systems that Implement Dynamic Spectrum Sharing Between 4G and 5G, Definition of Methods and On-Site Measurements. Thank you, Tiziana.
Thank you, everybody, for being here. So we will see how and if it's possible to assess how the population exposure to electromagnetic field is varied due to the system's 5G system that implements dynamic spectrum sharing with the LTE systems. So first of all, DSS is an acronym that stands for Dynamic Spectrum Sharing. Generally speaking, you can have dynamic spectrum sharing between any kind of technologies, but we think in this presentation to sharing between 4th generation mobile systems and 5G, 5th generation, so new radio systems. Why operators choose to implement this kind of technology? First of all, you have to think that with the implementation of 5G on the same band of a 4th generation system, operators didn't didn't have the necessity of implementing new base station. Moreover, we can have the use at the same time the coexistence of devices with only LTE technologies with the standalone new radio devices. There is an effective utilization of the low and mid band spectrum. And moreover, operators don't need to reform also the spectrum available for their services. In addition, you can have a dynamic coordination between LTE system and new radio system, new radio services, according only to the traffic load. And it is important, there is the possibility of a coverage of the area which requires services with a larger coverage of the area, because low frequency band allows a better coverage than mid and high frequency system. And for our purpose, there is a last advantage, which is, as Professor Pasquino said previously, in the 5G system, there are broadcast signals that needs to set a conversation between the base station and the devices, and there are then also the signal, the traffic beams. In the case of dynamic spectrum sharing, the traffic and the broadcast signals are the same beam, and this will be an advantage for the purpose we will follow. Then the spectrum sharing is obtained dedicating part of the host LTE frame to the transmission of the guest 5G signal. This can be obtained in different ways. One of these is by exploiting, for example, the radio resources that the standards dedicated to the multimedia broadcast multicast service single frequency network transmission, or subtracting some resources from one of the signal to make room for the control channel of both, and this is the technique of puncturing. Or at last by reshaping the power of the control channel in order to contain the interference, and this is the level rate match technique. For our studies, or better, the operators choose to implement the first technique, so to use the portion of MB-SFN part of the spectrum to 5G signal. And now we have to ask, this kind of technique has some drawbacks. Implementation of dynamic spectrum sharing rises the electromagnetic exposure of population, and are there techniques that we can use to measure this exposure? To answer this question, in 2020, we performed various measurement sessions to verify this situation. Measurements were performed in 3 different locations near Torino and in Puglia, in Foggia, and where used different experimental experimental asset. Now I show you. First of all, to compare the results, we prepared a measurement protocol that was the same for each location. And first of all, every one of us performed channel power measurement in condition of maximum load of the cell in order to estimate the maximum exposure achievable. Then in each location were performed decoding measurement on the 4G signal, and only in 2 of the 4 locations were performed time domain measurement, and actually in 1 of the last 2 were performed also decoding of the 5G signal. These only because just in 1 location, that was the 3rd location, that in Ivrea, it was available a spectrum analyzer that was capable of demodulating the 5G signal. As I said before, the traceability of measurement in different sessions was guaranteed by the use of a common measurement protocol and applying in every session the methods defined by the technical standards and the literature. So let us see what result we obtain. First of all, we measured simply the bandwidth of the signals, and this first measure gives us information on the fact that the DSS is active or not. In fact, as you can see, for example, in a 15 megahertz large band, we obtain that when only LTE signal were on, the band was smaller than about 1 megahertz. Then the largeness of the bandwidth in the case of 5G DSS active, and this is due to the fact that some resource elements are active to make room to 5G signal. So just with the bandwidth measurement, we can obtain this information about the presence or not of the DSS 5G signal. And these are the results obtained in the 4 different locations, and in every case we obtain this increase in the bandwidth largeness. Then another information we can obtain is a qualitative information. As you can see on the left, you have the signal of only 4G traffic signal, while on the right you have 5G signal traffic forced on the first one. So DSS is active. As you can see, the shoulder of the signal is much steeper in the case of 5G active. So also in this case, we have easily information about the presence of the 5G signal. Then, as we have seen in the protocol measurement, we perform channel power measurement, and in every location, the spectrum analyzer were settled with the criteria defined by the electrotechnical committee, and these are the results. So in the only one session, it was possible to perform measurement as a function of time. As you can see, at the dash white line indicates the time in which 5G signal is implemented, and the difference in color just give information about the large variation of the signal. This in the upper part of the slide is the graph or the picture of one frequency variation in time, and you can see that when only 4G signal is active, there is a large variation that becomes smaller, the largeness of the variation, when 5G signal is present. This only because in the case of 5G signal, it was possible to force the traffic, while in case of 4G traffic, it was the commercial one. It was not possible to force the traffic in that case. And however, the main result is that, however, the channel power measurement are not enough to give information about the maximum exposure of population to this kind of signal. Therefore, we performed vector analysis extrapolation on 4G signal according to the method defined in the IC standards, and we evaluated the value of the maximum electric field exposure using the proper number of subcarrier as measured before with the measurement of the bandwidth as seen before. Then I go faster because I see that I'm late. Then we perform other measurement in that site in which it was possible to demodulate also the 5G signal, and the comparison between measurement performed demodulating the 4G signal and the 5G signal gave us information that the measurement performed were exactly the same. So we can obtain, in summary, it is possible to check whether the mobile transmission system SDSS measuring the bandwidth. Then to measure 2.3, to measure the dynamic spectrum sharing signal to assess human exposure, it is possible to measure using the standard methods if the right number of resource elements are used. And the power dedicated to the 4G control channel and the 5G is the same. So maximum power extrapolation is also possible starting from a measurement of the 5G control channel. In this case, the extrapolation methodology is not set by technical standards, but are available on the literature articles. And in conclusion, tests on instruments and methods for measuring dynamic spectrum sharing signal generated by equipment from two different manufacturers were carried out. The tests were performed on the signals of 3 different operators in 4 different sites. Evaluation performed demonstrated that the measurement and estimation of maximum exposure levels are possible using tools and methods already developed for LTE signals, and implementation of this system does not change the exposure level. It was also verified that the same methods for measurement 5G new radio signals available in the literatures are also applicable to the detection of the SS signal, obtaining exposure estimates that are fully comparable with those obtained with the methods for LTE. Thank you.
Thank you, Tiziana. Are there any questions or comments? I think lunch is calling, maybe. Well, if not, thank you. Thanks again.
Thank you.
Tiziana, do you have any questions or comments? Okay, everything is fine. Thank you, Tiziana. From me and Marco, I think that it's time to go to lunch, and let me thank you for being here. No, it's not yet. Oh, the closing ceremony. I'm sorry. So it will be in this room. So just relax and wait for the closing ceremony. Thanks again for being here, and I hope to see you in next year second Metro living environment. Thanks again. Have a nice time here in Cosenza.
Good afternoon, and now let's start the closing ceremony of the first IEEE International Workshop on Metrology for Living Environment. This is the last step of this 3-day works, very interesting works and unexpected success as concerning both the scientific topics and the participation. So we believe that these topics will have a great future, and we hope this. So let me thank you, our guest, the University of Calabria and the Department of Computer Science, Modeling, Electronic and System Science, DMES, for their support and for to be our guest organization, guest place. A special thanks to the patrons. We have received the patrons from many political institutions and research institutes from all over the world, and also the sponsors, the department, DMES, H, Alma, Gibertini, Conforti, Distec, Feudo Liguori, Magnolio, DefTech, Integrated Logistics Supported Engineering, Sensors and Building Journals of the DPI. A special thanks to Athena. As you can see, they're always present. They always give their support. Thank you. And a summary about the participation to this first edition. We received the papers from 16 countries: Chile, China, Czech Republic, Germany, Ecuador, Ethiopia, France, Great Britain, Greece, Italy, Japan, Philippines, Poland, Russia, Spain, and United States of America. We have received 78 submitted abstracts, and we have selected 59 published papers, and we had 70 registered attendees. Thank you very much to believe to this project. We wish to thank the organizer of the special sessions for their cooperation and support to the workshop organization. Special session number 1, well-being and comfort of user based on environmental conditions. The organizer, Sara Casaccia, Università Politecnica delle Marche, Gianmarco Revel, Università Politecnica delle Marche, Cristina Jocchien, National Institute of Advanced Industrial Science and Technology. Sara, Gianmarco, please, the responsible, please, can you come here, please? This is a small present for you. This is a typical cookies of my region, of my city. It's cookies very ancient. The name is pitta impigliata. Impigliata means something that I don't know how to translate in English, but stitch. Okay. So it's made with the bread, pasta, and inside there are nuts and other sweets. So it's a sweets. So thank you very much for all your cooperation, not only in the special session, but really thank you for your friendship, first of all, and to all the efforts that you did to make this a success. Thank you
very much.
Thank you so much. Special session number 2, measurements and monitoring of energy aspects in buildings and in renewable energy sources. The organizer is Piero Bevilacqua, Università of Calabria, and Roberto Bruno. Piero, Roberto, are you here? You well know what is pitta impigliata, so thank you very much. Thank you. Thank you. Special session number 3, multi-domain. Thank you. Special session number 3, multi-domain measurements for personalized comfort management in buildings, organized by Marco Arnesano, Anna Laura Pisello, from University of Campus Marco, Anna Laura is from University of Study of Perugia, Enrico Fabrizio from Polytechnic of Turin, Anna Maria Buonamano, Università degli Studi di Napoli, Federico II. Are you there? Please come in. Marco, thank you. Thank you very much. Thank you. Thank you. My pleasure. Special session number 4, thermography and hyperspectral imaging for human health, building and urban diagnosis, organized by Stefano Laureti, University of Calabria. Stefano. Thank you very much. Grazie. Special session number 5, active and assisted living environments, organized by Jérôme Baudy, Christophe Laure, Dan Istrait, Sara Casaccia, Gianmarco Revella. So, please come. Another one. For sure. Gianmarco, thank you very much.
Impigliata.
Pitta impigliata. Thank you. Special session number 6, the challenge of resilient structures from traditional approaches to Internet of Things and structural health monitoring, organized by Elisa Bertolesi, Brunel University, Manuel Buitrago, Jose Adam, and Gabriele Milani. So, Gabriele, I hope you are here. Or okay, I will send to Gabriele. Thank you very much. Unfortunately, he has the problem with the train, so he had to go. But they sent his greetings to you. Thank you. So, move forward. Special session number 7, BIM for Structural Monitoring Application, organized by Alessandro Sabato and Raffaele Zinno. Unfortunately, they cannot be here. I don't know if Raffaele may be. Alessandro is in the US, and this is time for him of project, so he cannot attend, but he sent the greetings to you. Special session number 9, measurement techniques and procedure for quick and emergency diagnostic of buildings, organized by Emanuela Natale, Giulio De Emilia, Donatella Dominici, Antonella Gaspari, Marcello Marzoli, e Stefano Marcella. Are you here? No. Thank you. Thank you to all of them. Special session number 9, probability and mathematical statistics for living environment and metrology, organized by Antonella Giuliano e Antonio Di Crescenzo, Pietro Lio. And unfortunately, they are not here. Antonella has to come back to the university for institutional business. So thank you to them. Special session number 10, human exposure to electromagnetic fields in smart cities, organized by Nicola Pasquino, Daniele Franci, Tommaso Aureli, Settimo Pavoncelli. Please. Nicola, thank you very much. Thank you. Special session number 11, measurement techniques in urban, fluvial, and coastal living environments, organized by Francesco Ristodemo, Francesco Coscarella, and Nadia Penna. Nadia, are you here? Francesco and Francesco? No, I will bring to them. So they are near me. Thank you very much. Thank you to all. We take the pictures, thanks to Atena, thanks to Gianluca especially, and we will share this picture on the website of Metrolive Enva at this address, so www.metroliveenv.org, photo gallery. Some pictures, and then selected papers will be invited to publish their extension on Sensor Journal, MDPI Sensor Journal, MDPI Buildings Journal, Comunicasie, and Acta Imeco. So the authors who want to extend their papers, please select the journal and send to us, okay? I would like to thank the editor-in-chief to believe again to this workshop and to the topics of this workshop. Now we'll start the award ceremony. The first award, as announced 2 days ago, is yesterday, is best paper presented by young researcher. This award is sponsored by Sensors Journal, and the winner is entitled to a prize money amounting to 600 CHF, a waiver of the article processing charges for the extended version of the best papers on MDPI sensors, a signed and stamped official award certificate, the announcement of their achievement on a special conference web page. And the winner is experimental study on pore pressure attenuation in Ruble Mound breakwater in depth limited water conditions, authored by Giulio Scaravaglione, Stefano Marino, Leonardo Damiani, Antonio Francone, Giuseppe Roberto Tomasicchio, Alessandra Sponieri. Someone is here? Please. Congratulazioni. Congratulations. Thank you. Best paper presented by a woman. This award recognizes the best paper authored and presented by a woman. The best paper presented by a woman is sponsored by Tripli Women in Engineering, Italy Section Affinity Group, and Gibertini SRL. The author of the awarded paper and co-authors will be entitled to a professional balance by Gibertini, a signed stamped official award certificate, the announcement of their achievement on a special conference webpage. So, the winner is 3D modeling of existing asset based on point clouds, a comparison of scan-to-beam approach, authored by Sonia Alvarez Diaz, Javier Roman Semberanos, Agnesia Lucas Swenka, sorry for my pronounce, Piotr Daimaski. Is there one here? Thank you. Thank you very much. And thank you. There is the boxes with all the accessories is into the reception. Welcome. Thank you. Best standardization paper. This award recognizes the paper presented at IEEE Metrology for Living Environment workshop with the most significant contribution to the international standardization in the electrotechnical, electronic, and telecommunication field, with a specific focus on new mobile technologies. The author of the awarded paper and co-authors will be entitled to a free one-year membership to one of the CHEI technical committees at Winner's Choice, which includes participation to standardization activities and a lot of CHEI magazine and all CHEI and CHEI-N standards issued during the membership period related to the chosen technical committee. A signed and stamped official award certificate, the announcement of their achievement on a special conference web page. And the winner is how to characterize power lock systems for limiting exposure to electromagnetic radiation generated by 5G MIMO systems, authored by Sara Adda, Stefano Coltellacci, Daniele Franci, Nicola Pasquino, Riccardo Suman, Mattia Voccarono. Muoviamoci a favore di bandiera e di camera. Nicola, congratulazioni. Congratulations.
Thank you so much.
Best Conference Paper Award, third classified. This award recognizes the most outstanding paper, third classified, presented at the IEEE Metrolive M workshop. The awards are sponsored by MDPI Buildings Journal. The author of the awarded paper and co-authors will be entitled to a prize money amounting to 200 CHF, a signed and stamped official award certificate, the announcement of their achievement on a special conference web page. And the winner is use of laser scanner and total station systems in fire resistance test of a closing element, authored by Massimo Bonifati, Marcello Lombardini, Carmine Castaldo, Fabio Mazzarella, Marcello Marzoli. There is someone here? No, however, congratulations to them, and we will send them the prize. Move forward. Best Conference Paper Award, second classified, offered by Buildings. This award recognizes the most outstanding paper, second classified, at IEEE Metrolive M workshop. The author of the awarded paper and co-authors will be entitled to a prize money amounting to 300 CHF, assigned the stamped official award certificate, the announcement of their achievement on a special conference web page. And the winner is modeling the thermal response of the human body for thermal comfort assessment in indoor space, an experimental validation. Authored by Giovanni Barone, Cesare Forzano, Giuseppe Russo, Ilaria Pigliautile. Anna Laura Pisello. There is someone here? No. So, yes, please, Marco, thank you. Thank you. Just a spot, however. Marco, thank you, it's a pleasure. And now, a prize that is very significant for many of us. It's the Best Conference Paper Award that is dedicated to the memory of Professor Domenico Grimaldi, whose passion, enthusiasm, and commitment for science will be of inspiration for all the recipients of this prize. I kindly ask to Andrea Aiello to come here with me. Andrea, thank you very much to support this prize. And this award recognized the most outstanding paper presented at a EEE Metrology workshop. The Best Conference Paper Award is sponsored by Alma Software, and Andrea is the CEO of Alma. The author of the awarded paper and co-authors, if any, will be entitled to a prize money amounting to 500 euros, a signed and stamped official award certificate, the announcement of their achievement on a special conference web page. And the winner is measurements and characterization of energy-related behaviors and indoor environment quality in residential buildings using a wireless sensor network, authored by Mathieu Bordeaux and Julian Wavsten. Is there someone? The authors? For sure, one of the authors I've brought to the bus station yesterday evening. So, however, we will send the prize to them. Thank you very much. Thank you, Andrea. And now, next step toward the future. The second IEEE International Workshop on Metrology for Living Environment. We are proud to announce that it will be held in Milan, Italy, in May 29-31st, 2023. Now, Gabriele, unfortunately, I said you before, has to go to take the train, and I will present his presentation. Important dates. Tutorial and special session proposal deadline is the 13th of December 2022. Extended abstract submission deadline March 21st, 2023. Extended abstract acceptance notification April 11. Final paper submission April 30. Honorary Chair Professor Pasquale Da Ponte, General Co-Chair Gabriele Milani, and myself. Call for special session. We are opening the call for a number of different special sessions. Please send your proposal through the procedure on the website conference. Particular attention to two topics: damage assessment, diagnosis and monitoring for the restoration of CH, IoT-based systems for the cult structural health monitoring, architectural survey, and the analysis of cultural heritage building and archaeological sites. Obviously, all the topics of this year's and other topics that you would propose to us and that are arising from this discussion of these days are warmly welcome. So please send your proposal. Awards. We foreseen as Best Paper Award, Best Paper presented by young researcher, Best Paper presented by a woman, but we are still in contact with other committee and scientific institution to organize further onward. How to reach the Polytechnic of Milan? If you land at Linate Airport, you can take the Airbus to Central Railway Station. If you land at Malpensa Airport, you can take the Malpensa Express train to Cordona Railway. If you land at Orio al Serio Airport, you can take the TerraVision bus to Central Railway Station. However, all the information will be available on the new website of MetroLiveEnv. You can reach the website at the same address, metroliveenv.org. This is the venue of the campus. The campus is Leonardo Milano City Center, Piazza Leonardo da Vinci. And as you can see, the underground train station is at 50 meters from the place of the conference. So, see you in Milan 2020. Thank you. We can declare closed this first edition of IEEE Metrology for Living Environment. Thank you very much.